Okay, so welcome to week 5. Yesterday we did something on Redis. We cached our API, one of our API, the API to post to fetch posts on the application. So I will share my screen now so that we'll have a brief recap of what we did yesterday. I think it was just doing that was here yesterday. Please confirm you can see my screen. Okay.
Yes, I'm confused.
All right. Okay. So yesterday we did something on Redis. We downloaded Redis. We installed it, and we configured into the application. Here is where we configured it. We downloaded the package. We downloaded the software and installed it to the system. Then we installed a package, npm package into our application that will help us to configure Redis and communicate with the Redis server in our system, in our laptop. Right, so this is it. This is the host, the IP, the host, the IP of the of Redis. When you install it into your system and you run it, it will run on your local host or this IP address. Then this is the port, the default port for Redis. So if you set up this configuration this way, you'll be connected to Redis and can now configure it into your system. So basically, what does Redis do? Redis is actually for caching requests in your application. When you there are some endpoints that you need to cache in your application when you build that API. So those endpoints, you cache them if they are not frequently, if they are kind of they take time to load, and the data they fetch are not frequently changing almost every time. So you need to cache them. And what caching do for you is that those when you fetch those data initially at the first call, when your API fetches those data from the database at the first call, it's cache it in your application, in the application, the RAM of your system, your server, so that anytime you try to fetch that data again in the future, instead of going to the database to fetch it, it will fetch it from your system because it's already stored on your system. So basically, that's what cache do for you, and it's because of that, due to that, it makes your that API efficient, fast. So instead of going to the connecting to the database and fetching it, it won't go to the database to fetch it from your system because it's already cached on your system. So that's one of the ways to make your APIs performance, highly performant. So yesterday I said from what we'll be doing today, from this week onward, is all about making our application to be efficient, performance, scalable, and the rest. So Redis that we introduced yesterday was is part of the ways to make your API scalable. Yes, to make it perform very fast. And today we'll be discussing Docker. Docker is also one of the ways to make your application portable, right? Portable and available. Like the availability will be high because when you run your application using Docker, there is some configuration you use that make it that anytime you host your application in the server, if it shuts down, maybe something happens, it shuts down, and the server comes on back, the Docker will start your application back for you. You don't need to start going back, logging into the server to start your application back by yourself. Docker will automatically start it up for you, right? So that characteristics is actually making your application to be highly available, so that the downtime will be very low. So Docker will just be helping you to restart your application anytime it goes down. So that's one of the things. So by next week, I'll be introducing Kafka. Kafka is also um, basically to help your application, to make your application scalable also, right? Because it has to do with writing. Redis has to do with when you are reading from database, your application is reading from database, fetching data to users, to show users, right? Basically, that's what Redis does. But Kafka in this sense now has to do with writing to your database. Like if you have an API uh, that's receive high volume of data right into your system, you can use Kafka to configure those kind of API, because if you don't configure that endpoint very well, because of that high volume of data, it's going to lag your system, and your that particular endpoint will not be efficient if you do it if you if you configure it the normal way that you just configure your APIs. That particular API that receives high volume of data to insert to your database will be very slow. So use Kafka to optimize those kind of APIs, right? Which we're going to demonstrate by next week. So basically, that being said, we're going to now demonstrate Docker. This is the project. So I don't know. Do you guys need me to recap on the configuration we did for Redis yesterday?
Yes, sir. Thank you so much, sir. Thank you.
Okay, so let me briefly discuss that. But tomorrow, today I will post the video, and I'll post the video. You can just go through it. But before that, let me recap on what we did. So, like I said, this we configured Redis. This is the configuration. So when you install, I asked us to install Redis in our system, but I told us that if you don't have Redis, you can leave it. We use Docker for that, and I'm going to show us how we're going to use Docker for it here. So if you have Redis installed in your system, you're going to have access to two items from Redis. You're going to have Redis-CLI and the Redis-server, right? The Redis server is the engine that's do the whole the server itself that do the caching of data, store the data in your system for you, right? Why the CLI is what you use to communicate with the server, right? So if I do this, I will see the version. Then if I do, it shows that Redis is installed in my system. If I do this, you also see the CLI. Then how do we use Redis? So I'm going to show us a demonstration of what it actually mean to cache data, right? To cache data in the system. So let me show a demonstration with the CLI. If I do CLI and type enter, you can see I am now, it has changed to the host and the port, right? So it means I'm inside Redis now. So if I want to cache a data, let's say I want to cache my name, I want to cache a string. You can cache any type of data, right? I want to cache a data. So if I do set, I give the data name, like what name do I want to give this data. If I do full name, then I now give it uh, Christian, right? My full name, and click enter. I see I have cached it. If I want to retrieve it, I do full name, I'll retrieve it. It will bring it back for me, right? So basically, let's assume now that okay, we want to cache the data that we fetch from our database, all the posts, right? We want to cache all of them. You can just cache them. Just do set um, posts. Then we give it the value. The value, let's say it's an array of posts. Post one, post two, and so on and so forth, right? So if you do this, if you want to get it later, maybe somebody want to fetch that post again, instead of going to the database to fetch it, we just call Redis and check. Redis will return it to us. So let's see how this thing now is applied into our application, right? So now we have configured our Redis. So after we configured our Redis, I came to this provider folder. I told you guys these folders that are here are very important. So I came to this Redis providers, and I created a redis.provider.ts file. So what is inside is this. I created a class called Redis service, right? So this is where I wrote this. We created two functions yesterday. Want to set cache for anything you want to cache, and you want to get it, right? So this function here, what it does is this thing I first did here, this sets, right? It says anything to set the to set your cache, to store your cache, your application. That's what it does. Then this other function, right, is to fetch, right, is to fetch. If you give it the name of the key of the items you cached, it will return the value to you, right? So basically those are the two things we did. I created the two functions under Redis service class. So when we created this thing, now we exported the class, we can now use it in any way we want to, any API we want to cache the data, right? So now we came to want to cache the post, because post, when post is, to fetch post highly, it has high volume of data you can, so we want to cache it. So what we did was we came to the service layer. We didn't go to the controller. Controller, we don't want to be writing too much code in our controller, right? We came to the service layer, and we went to the method that fetches all posts, right? This method gets all posts. So we came here, we said, okay, we imported the Redis class. This is where we imported the Redis class to our constructor. This is it. We imported it into our constructor. So when we did that, we now say, okay, we can now use it, right? So this is the item to, right? So this is the item to get. So basically, when we call this function, right, it will first check. We'll first check on in Redis whether we have posts already stored, right, for the request to get to fetch posts, whether we get items already stored. If we got items, right, this is it, cache post, that we have cache post, we'll return it, right? We don't need to come down here to query the database. This actually querying the database, right? So because if we get our post here, we've gotten the post, means we have a post, we will now return it. This if is actually to check if we have post, because this will either return null or value, any value that will store. So as you can see, it's array, it returns its type of array of post or null. So if it is not null, we'll return the post. But if it is null, this means it will continue down here. That if we continue, that means we have not cached the post yet. We don't cache the post yet. They will now query the database, fetch the post. Then when we get the post, we'll now cache the post with this set item cache, right? We'll now cache the post, then we'll return the post, right? That's the first step. That's the whole flow. I mean to say that's the whole flow. Then when this is done, so how do we how do we get cache and set cache? Remember, when we are here, this demonstration, we use when you are setting, you use key, you set the key you want to use. Here I use full name to store my names. I use posts to store the post. Yeah. So but in your application, you need to make the key kind of like more elaborate on what you're doing. So basically, get fetching post has to do, you have to paginate the post, the page and the limits of that particular post you are fetching. So to get our cache key, to generate our cache key, we use post. Post here means we are caching posts, right? We can be caching comments, right? If you go to comment part, we can cache comments if we want to cache comments. So if you are caching comments, we would have to use comments here to differentiate post from comment and from any other item we are caching. Then also we apply page and the page number. So we are caching for, so if we cache for page 1, for example, um if we cache for page 1, we can cache for page 2 also, right? So if we cache for page 1 and we are trying to access page 2, it means it won't be in our cache because we only cache page 1. Then later when we execute the query, you can cache page 2, for example. So all these are just variables that you can cache different posts, right? So these things here, is that is a bit like is your own, how you want to define your key. Like it's not the principle, it's not the way, the authentic, it's not like the standard, like you must do it that way. No, it's any way you want to define your key to cache your post, right? So when we do this, our post endpoint is cached here. So when you do this, you are good to go. So basically that's about the caching. So after this, you don't need to configure anything again. You don't need to come to the controller to configure anything. No, you just need to um, cache, just do your thing here in the service controller. So that being said, now I yesterday, so when you've cached your posts, there's what they call invalidating posts. Let's say for example you cache posts, you've cached all your posts. Now you need to, when there are new posts that are being registered, that are being submitted or posted in your application, it means that if you, let's say you are caching 10 posts, right? Your all your posts are 10 and you've cached all the 10 in your system, and somebody created a post again, all right, to make it 11. So it means the 10 you cache is now invalidated, is now outdated, is now stale, because you have 11 in your system, but you're caching, so you are caching 10, meaning the new posts you don't have it in your cache. The new post that's created in the database now that somebody has posted it from your application, you don't have it in your cache. It means you need to invalidate your cache, right? Invalidate your cache so that when somebody try to fetch all the posts, it means they will get the new, both the old one and the new post together. So when, so you need to invalidate your cache. You need to add logic to invalidate your cache, and to do that, you put logic to invalidate cache in endpoint in the services that has to do with anything, any endpoint that has to do with updating, creating, updating, and deleting of that entity you cached, right? If you cache post, right, you need to go to all the endpoint that creates posts, that updates posts and delete posts. You need to go there and add the logic to invalidate the cache, so that anytime somebody creates a post, it will go and it will, you need to delete all the any cache, any cache of any post cache that you've stored on your system, right? So with that, that's what I wanted to demonstrate for today, because yesterday we just added the logic to cache the system, but we need here now, I want to add the logic to invalidate cache. So I'm going to add a logic to invalidate cache in this create post, then we'll do that for update posts and for delete posts, so that all the any new updates that are being made to our post will not be caching the old updates instead of caching the new one. So let's do that. Then after that, we'll now move to Docker proper. So to invalidate our cache, we need to look at items like just to delete the item entities. So I'll come to my service here. I'll come to my, hold on, let me confirm something, please. So yeah, we need to, so we'll come to our provider. We'll come to our provider. We need to add the function to invalidate cache, right? So that anytime we'll just call the function in the service we want to invalidate cache. So guys, I don't know if I'm making sense. Maybe I will so now our function will take key of the item we want to invalidate, and it's going to be string. So it's going to return promise or void, the normal return value. Then now we'll do this, get a stream, then this Redis, that's the Redis configuration. We want to the Redis, want to access the Redis server, scan stream with match key. So anything that match the key we want to invalidate, should just remove it for us. So keys do are going to be array of string. So let's loop do keys if we have anything inside. We delete. Okay. So guys, so hello guys, hope you can hear me. Please give me thumbs up if you can hear me.
Yes, we can hear you.
All right. So um, this is the function. What we did here is just we got the key. Like let's say we want to validate posts, right? We want to invalidate posts. Then we are storing different posts. Like we are storing different. We are storing posts with different keys. We have something like we in this. Okay, let me go to that our service here. Let's come here. Yes. So like here now, if page is let's say 1 and limit is let's say 10, right? So the key, the key will be post page 1 limit with 10. If page is if page is 2 and limit is still 10, the new key will be different from the first one to be page 2 limit limit 10, right? So the data this one will store will be different from data this one will store because the keys are different, right? So now when we want to invalidate everything on post, right, we give it this, we call that function and give it post. So when we give it post, it will search for all these things that are here, all these keys, any keys that has post, it will search for them and delete them. That's what we are doing here. So when you give it key, we give it post, it will, this function here we stream looking for anything that has post in the in the Redis and fetches them. If it gets them, this is where it puts them to searching for them, putting them inside this array keys, and then after doing that, it will now use this function, call this function redis.delete to delete all the keys. So when this is done, you don't have any cached post data, right? So this is what we call invalidating the the cache data. So to after we finish this function, let's go to our Redis service and call it basically. So when we come here now, we are here. We need to invalidate when anytime we somebody creates a post, we need to invalidate our post cache. So to do that, we just call after inserting. Let's invalidate it here. After inserting, we just create the cache key. We'll just call it post page. So this is the key. Then with this, it will do the scan and check for all the other elements. Then this Redis, we call Redis dot invalidate and give it cache key. So basically, this is it, right? So anytime somebody creates a post, we have to delete all our cached post data on the system. So let's copy this now to the next to update. Anytime somebody updates the system, the any post, we need to invalidate the cache, right? Anytime somebody deletes a post, we need to invalidate the cache so that we'll get this is just to get the updated record now from the database. So when we do this, everything is now secure and fine. So this is fully this I would say this our endpoint post endpoint is fully cached, right? So let's do a demo on this. Let me see. terminal to come up. Okay, we run our environment, run our server, come to Postman. All right, so I'll leave this console log here so that we see what is happening in our server. Because when we cache data, we will see it. Okay, our server is running now. Need Postman to start up. Okay, Postman is up. So this is, let's call this endpoint and see if we have cached data. If we have cached data, it's going to console log it here in the server here for us to see. So let's call it. Okay. Okay, we've gotten our data. Let's see if we have if we, so okay, it didn't cache any data. There's no data cache already, so everything is null. So this return, there's no cache data, it's returned null. So basically the data, this data here that is returned, this data is returned is directly from the database, right? Because it came here and queried the database directly. So if I call this function again, you're going to see it's going to be faster now. Yeah, it's very fast now, and it's because it's cached, right? You see, we now got something console logged in our console, right? If I scroll, because this is the this cached post here is the data that is already cached. Sorry, right? This is it. So the first time it was null, but the second time I called that endpoint, it's cached the the post. It logged out the post that it cached, so we saw it. So the second request was actually from the cache. So now let's try and let's see if our invalidate endpoint actually works. So let's try to create a post. So if I come here and let me create a post. I think I'm not logged in. Maybe to tell me, okay, the token is still valid. So I have, I created, right? So by now, this data that is cached on the system would have been deleted, right? Would have been deleted. So if I call get post again, I will see that cached post null. I will see it here because this data that is cached has been deleted. So if let me call that endpoint again that we're supposed to log. So supposed to log post. If I call it, see, no, this is not this one. Yeah, I see. It's logged cache post null because when I created the new post, it deleted that endpoint. It deleted the cache post that we have here, right? It was deleted. So when I call this fetch post now, I got null because there's no data again due to the fact that when I created the post, the cache data was deleted. So if I call it now, if I fetch post again, it's going to log because see, it's now logged. It's no longer null. So basically that's this is it. If you are able to configure an API this way, it means you have successfully cached that API. You won't be having stale data cached in your system, right? So guys, this is it. I'm going to post this code on the. I'm going to share this code so that we'll see how everything is being implemented, and also implement it in our own version of the code. So guys, this is it. Let's now discuss Docker, right? Let's discuss Docker. I have a slide for it. Okay, let's see. All right, let's go to lectures. So, what is Docker, and why do we need to Dockerize applications, right? So, like, if you build an application, if you are starting off building an application, there are instances where you, after building, coding everything, writing all your code and everything, and you deploy to the cloud server. Now, when you deploy to the cloud server, cloud server is just like another system, right? But it's virtual. So when you log into the services like AWS or DigitalOcean or GCP, that's Google Cloud provider, if you log into those platforms, when you sign up, you to get a cloud server, you sign up, you set up the system and everything, you configure, you choose whether it's going to be Linux operating system or Windows operating system or Mac operating system, right? So just like your normal laptop that you have, so you have to choose those things. Then after selecting the system, the RAM, you also select the RAM and all those configurations. Then after doing that, you now log in into those system. You log in from your own laptop into those system. Then you push your code, right? Either from GitHub. So when you do that, and when you've imported your code into those cloud servers, you need to install dependencies and everything. So installing dependencies and doing all those things, maybe if it's a node server, a node application you wrote, maybe Express or Nest.js, you need to, in that your cloud server, you need to install Node.js, yes, and some other items that you need, right, to deploy. Yeah, Node.js basically. The way you do that, and you install try to install the dependencies in your application. When you install the dependencies, you're going to see that sometimes you may get errors, like the application may not work in your class server, right? It may not work due to dependency issues, dependency difference. Maybe the node version is not what you expected, or the rest. So all those kind of complications, all those kind of things, like or maybe even your co-worker is trying to take those your application and run it in his system, and due to packaging differences, version differences, it may not work. So these kind of issues, portability issues, is what Docker actually try to resolve for us, right? Just so that when you build your application, you Dockerize it, you can take it anywhere. It will execute. You can take it to any operating system, it will execute. As far as that operating system has Docker in itself, your application is going to work, right? So that's basically what Docker does for us. So Docker, if you go through my slides, say it's a platform for building, packaging, and running applications in lightweight containers, right? It ensures consistency across environments. Works on my machine, solved. Yeah, this problem works. It works on my machine and the rest. So, the ideology, the way Docker solves this problem is that it takes your application. When you say I want to Dockerize my application, basically just like you take your application, you put it inside you create an image, Docker image of your container of your application, and you put it inside a container. So it's just like you're containerizing, putting it inside your container, inside a container. You take your app and put it inside a container. So that container is where it's going to execute, and there will be no problem. All the things you need, just put it inside there. It will work without any problem, right? So this is just a graphical representation. So if this is the server, you serve the server platform, This is the host operating system. Yes. Hello. Is anybody trying to call my attention? Oh, okay. So let's continue. So, like this is the operating your server, the host operating system. Like in this my laptop is Windows. In the cloud server, where you want to deploy your application, could be Linux operating system. Then you have Docker. You need to install Docker. So that Docker you come with Docker engine, right? So you need Docker engine in the application. Then when you do that, the your Docker containers, your app containers of the Docker image you created will now be will now reside on top of the or inside the Docker image, because the Docker engine, the Docker engine is going to be the one responsible to handle them, right? So this is just a pictorial view of everything. So instead of, if you remove Docker, it means your application here and the right libraries will just run on your operating system, and the operating system may differ, and if they differ, some of the packet the items softwares they need your application needs to run may differ in versions and everything. So but using Docker and containerizing all your application will just make everything easy and swift. So why it matters? We have portability, that's the first thing. Speed, yes, it can speed up your application. Reproducibility, yeah, because you can take your application, give it to somebody, and the person can just run your application easier DevOps workflow. So high level, like everything about Docker. This is just how we imagine everything. So you have what we call Docker images, right? That's the basic idea there. Docker images. You have Docker containers, right? So it's from images you get a Docker container. Docker containers are just like running images. When you create your application, when you Dockerize your application, you create an image of a Docker image of that your application. Then when you start running your application, it's basically running in container. All right, it's running as a container, Docker container. Okay, so how do we create? When we say we are creating a Docker image of our application, what do we actually do? You use what we call Dockerfile to create the image. So any application that you want to create, you want to create image Docker image of, you need to create a file called Dockerfile, just like this, simple, just Dockerfile. Then you put some Docker instruction in the Dockerfile. All right, so Docker engine is where is the engine, like the server, everything that handles your Docker application, right? Your Dockerized application. So that basically that's what it does. Then Docker Hub is the registry where we publish our Docker images to. Okay, it's you going to see that in the demonstration. It's just a URL. It's just like a GitHub. GitHub is the home to most codes that we write. If you write your code that you can deploy to, you can push to GitHub. Basically, the same thing with Docker. If you Dockerize your application, you can push the Docker image to Docker Hub, right? So we have volumes, just like we have images, we have Docker volumes, right? You can create Docker some stateful some stateful applications, Dockerized applications have volumes, right? Like we're going to explain that. We're going to show you what it actually means. So we have networks, Dockerized images, Dockerized services. They communicate via when they start running. When Docker container starts running, maybe you have very different Docker containers running in your system. The network, they communicate via network. They create Docker automatically creates some default network for those services, Docker containers, to communicate via each other. We're going to see that in demonstration. So just for us to know this concept. Okay, so what is an image? Image is a read-only template instructions for creating containers. Yeah, built from a Docker file. Like I said, yeah, built from a Docker file. You want to Dockerize your application, you're actually creating a Docker image of that your application, and you use Docker file to do that. All right. Then when you created your Docker image of your application, you can store it in Docker Hub, yeah, in registries like Docker Hub, GitHub packages, and the rest. So examples, we're going to see something where we start going through Docker file. You're going to be seeing something like this: Node, Node, Python, and MySQL. So what this actually means is this is a Node image, right? This is the name of the image, which is Node, right? Then this thing here after this colon is called the tagging, right? It's called the tagging. So basically here it says from this tag I can say this is a node version 18. This is a node image of version node version 18 um, built on top of Alpine Linux server, Linux machine, right? So that's how we can interpret images this way. And you can, when you build your own Docker, when you Dockerize your own application, you can tag it this same way, this way, right? The way you choose to tag it, right? Basically. So what is a container? A running instance of an image. Yes, container is a running instance of an image. So when you dockerize your application, you've created the image, an image, Docker image of that your application. Then when you start executing it, that's when there are commands to create image and there are commands to run that image you've created. We're going to see it, right? So when you run your command when you run the command to run that image, means that image has become a container. It will start running as a container. So lightweight, it's lightweight, isolated, uses shared OS kernel, right? So this is the command, docker run hello world docker. So we're going to see all these commands in action. So this is basically the whole thing here in just one diagram. So when you use docker file to create to dockerize your application, then when you've added docker file to your application, you build it. The building will create a docker image of your application. Then when you run it, it becomes a docker container. It runs as a docker container. So it means your application will be running. So let's look at the Docker architecture. There are three major components. You have the Docker CLI, the one we'll be using the command line to write our command Docker commands. We have the Docker daemon, which is the engine. So that's what actually manages the images, and the containers and the rest. So we have the registry. Registry is Docker or where we Docker where we store our images when we push our Docker image to. Right, so let's just have a brief intro. So introduction to Dockerfile. A Dockerfile is a script that tells Docker how to build an image, right? Dockerfile is a script that tells Docker how to build an image. So when you've created your application, you just to Dockerize, you just create a file called Dockerfile. It has no extension. Just call it Dockerfile. It has no extension, right? So when you do that, you can put instructions like this. So this is a basic um, Dockerfile instruction to create to Dockerize a Node application. So this you can use this for any Node.js application, any Express.js, any Nest.js, any React application, any application that runs in Node runtime. You can use this file, this content to Dockerize that image, to Dockerize that application. Okay, so let's have a look at what this instruction do. So the first one is from. Docker images start from, right? So it means is the base image. When you see from, it follows with an image, right? So what it means is that I am building my application on this, like the base image on this Docker image. I'm building my application on this Docker image. Okay, so when we do that, I will now specify the work directory. Work directory is basically like the in my image, in the Docker image, in Docker image system. Hello. So in the Docker image system, I am creating a folder called app, and it is in this folder that's all the app, my application contents, all the my project is going to reside. I want to store it here. Right. This is basically what you're doing. You're creating a work directory of your application inside the Docker image. All right. So let me explain this one again. This from node colon 18 hyphen hyper means that I am creating my application in an Alpine Linux system that has node version 18. So basically this will create a node Linux environment for you that has node version 18 inside of it. That's what this will do for you. If you use node version 22 for your application, you have to update, look for the image that has node version 22, right? To use the image to use. Just change the name of the tag here. It will, it will update like that. So where we create the work environment, then copy is like copying files. Everything is just self-explanatory. Copy is like I am copying this package.json, right? Everything package.json. Like if you check your application, we have two package.json entities here. We have the we have this and we have this. We have package.json proper one. Then we have package-lock.json, right? So what that command copy does is that it copies these two items, right, into your Docker first. So that's why we have this asterisk here. Asterisk means package and anything follow any character that follows it, then ends it .json. Copy it into the work directory, which is this. It will copy this and put inside into this directory here, and which is this work directory. So when you have copied, if you notice you have not copied your application code. It's just the package JSON that you've copied, right? When you do that, you can now run your install. So when you do this run npm install, so this cron command will now run your normal command. Like when you want to install packages in Node.js application, you run npm install. So that will install all the dependencies without your code. The code has not been has not been copied yet. It just installs the packages, right? Now then you now copy. Now you now copy this next copy. Now we now copy your code, all the code base, all the your codes of your application. That is copying everything. Here we not specify, we just specify dots, then dots. So it means copy everything in my current the root folder to the root folder of my working directory. So when that is done, now your application is supposed to run in port 5000, right? Then you have to expose the ports, expose ports. But I think this is optional because when we are running our container, we need to specify port also. So, but you need just expose the port so that your Docker container we know that okay, this port is open. Should open the port. Then CMD is like the to start your container. This is the command to run when you want to when you want to run the container. You want to run the image to to run the container, right? When you do that, write that command to run. This is what Docker looks for and execute for you. It looks for it and executes for your project. So the command I use to start your project, you need to put it here. npm starts. It's going to put this thing line by line. So you're going to write npm starts, right? That's how you're going to execute this. So this is just a basic Dockerfile configuration. So if you add this to your Dockerfile, automatically you've Dockerized your application and you are good to go. So let's look. So when you've created your application, right? So I think I need to let's just demonstrate this thing so that we'll have a all right. So here, guys. So let me comment. Let me create the file. Okay, so from node, what node should I use? Okay, it's node version 20. So guys, this is it. So I'm creating Docker file now. Guys, hope you're following, right? Hope you're following. Yeah, I will share the notes. Share notes, yeah. I'll share everything. I will share everything. Right, so from this, so let's create our work directory. Right? Then the next thing is to copy our package.json. You can just put it dot this way. Then when we copy, we'll now run npm install. Then when we do that, we'll now copy the whole code base. The whole code. Then when we do that, can now start our application. cmd. Alright, so this command, this npm start is actually going to execute the command here. This is our npm starts here, we specified here. So when we do this, we have dockerized our application. So let me build this application. Let me build the image. Right, I have dockerized it. So to build this application, we use this command docker build -t my app and these dots. Right, so this my app is the name I want to call the application, the image, I want to call it. Right, so let's go back here. So since I have created this docker file here, right, let's do docker build. Right, I am building the image. -t is tagging. There's what they call tagging of your image. So basically this image here, this image that I'm pulling from, this is my base image that I'm building my application on. This is the tag, right? This is the tag. You can tag your application this way, right? So here I want to tag my application this. I want to give my own image this way. So I want to call it blog blog server. Let me call it latest, right? Latest version or anything. Then I'll put dots, right? Now why did I put dots here? So I'm putting dots here to let Docker know that, okay, the Docker image, Docker file that you're going to use to build this my application is inside this same path I am writing this command, right? So because when you run this Docker build, Docker is going to look for the Docker file to use to build your image, right? So when you specify these dots here, I'm telling Docker that, okay, the Docker file is inside this same place, inside the same directory, right? If I create a directory and add this Docker file inside that directory, I'm going to specify it. Let's say I put a directory here, so I'm going to do it this way. That's okay. Look for the Docker file inside inside this directory that I'm going inside this directory, right? And it's going to be the Docker file is going to be inside it. So, but since the Docker file is inside the same directory that I'm running this command, so I'm going to just use dots here. Don't forget these dots. If you didn't add it, Docker is going to complain. There's going to be a problem. All right. So since now, if you notice, guys, I quickly rename this thing here docker.archived, right? Because the content of this one is kind of complex. I didn't want to use it now, but I'm going to explain it later. That's why I just created this one to show us, to demonstrate to us. Now, but when you are building applications, you may have two different Docker files that you need to you use to build your application. Maybe you want to you want to use the Docker file for for development environment, and another Docker file when you are deploying. You want to build the image of your application in when you are deploying it, right? So to specify which Docker file to use, right? To specify which Docker file to use, like if I want to use this Docker file dot archived here, I will do this. I will use this flag here. I will use -f. When you do -f, you now type the name. So what Docker will do is that it will now look, instead of using a Docker file, it will now use Docker file.archive, all right, to build my image, right? So you can specify a different type when you rename the Docker file to, like, you add something to it. that the name has changed from normal Docker file, right? By default, it has changed. You need to specify the file name, right? So, but if you are using just if you are using just Docker file, you don't need to specify the file. Docker will by default to search for Docker file, any Docker file by name. So let me read that. So let me enter run command. We're going to see, and to run this, we need to confirm that Docker is running on our system. Like, you go to your Docker desktop and open it. You need to confirm that Docker is running. So it's building our image. Pay attention to this blog hyphen server I created. This is the name of our image. So when I try to look, I'll try to look for the Docker image that has this name. So it's building our image for us. Okay, still building. Still building, still building. So we'll build this image and we'll deploy it to Docker Hub, to Docker Hub, so that anybody can pull it and run. Right? Can pull it. You can just do Docker pull and run it. And sorry guys, please pay attention. There's something I forgot to mention. Please pay attention. Now, before you create your Docker image, right? Before you immediately you create your Docker file, before you start building your image, you need to create this something a file called .docker ignore file. .docker ignore file, right? You need to have it in your system. You need to create it immediately. You just created your Docker file. You need to create it. Now, what does it do? Why do you need it now? Um, you need it to exempt some files that you don't want inside your image. There are some files that you may not want inside your image, your Docker image, right? Some sensitive files, some files that are not needed, that are not too needed very much. You need to ignore, like remove them from your Docker image. So here, when you create docker ignore, just docker ignore, nothing again. You need to add some items. You need to, exempt node modules. You don't need node modules in your image. Then you don't need your secrets are stored in .env file, so you don't need your .env. You don't need your secrets inside your image, right? Because if you store your secrets inside your Docker image, some people can, get your Docker image and be able to extract your secret from it, right? If they are able to reverse engineer it. So you need to exempt these secrets, right? Then some other things, many things you need to exempt from your Docker image. You need your Docker image to be clean and beautiful, to be easy and lean as possible as it could be. Even the your compiled folder, the distribution folder your TypeScript is going to compile files into, you need to exempt them, right? I'm going to share all these things with you, right? So basically, you need to create a Docker image, Docker ignore file. It's very important to do that. It's very very important. Okay. All right. Let's see. Okay. I think the build, it did not build. Let's see why it didn't build. npm. Ah, I made a mistake. I didn't put command here. Sorry. It's supposed to be command in this array of scripts. So let's rerun our command. Okay. npm install. Did you mean npm install a package? All right, let me use the other command, which is use this. So when you are building your application, it's better you use this command on the server because it makes more sense. This CI npm CI is better than the. As you can see, the Docker was complaining about the npm install, so use this one. This legacy pair dependencies is had to do with npm package, dependency issues and the rest. So you just have to use this command to build. So when you finish building, let me open another terminal and show us something. So to see all the Docker images that I have on my system here, I can just do. I can use the command, or I use this GUI, right? So this is all the Docker images I have. So this one is being built. Yeah, I think it's already built self. Yeah, the image. This is our blog server here. Our image. It's already built. But I just want to make sure that there is no issue. All right, so there's no issue here. So everything is done. All right, so this is the image we built. I should have showed us before. All right, so if I do Docker image to see all the images that have been built, just Docker image list or ls, right? If I click enter, now this is all the image here. So this is the new blog, the image we built. If you check, created 52 seconds ago, right? So it was created 52 seconds ago. It's the newest image that we created, right? So our application is, we have dockerized our application. This is the image, right? We can now run this application, right? Okay, see now, you see, I'm not running any application here. If I go to Postman, if I come to Postman here, if I run this, try to access this now, see, I'm getting error because our server is no longer running. It's not running. Yeah, but see, I'm going to run this new image I created. Let's run it and see how it's going to work. This Docker image. So to run a Docker image, you do Docker run, right? Then you give it the name, which image you want to run, blog server, right? You now specify the port, 5000, 5000, right? So our application is running in port 5000. So when we run the Docker image inside the Docker container, right? Our application is going to be running in port 5000 of the Docker container, right? Now, automatic by default, we can't access that Docker container unless we map, do port mapping. There's what we call port mapping between the container host of your application and your local machine, like local the server host of your application, right? So this port mapping I did here, this is what we call port mapping. You use -p to map your port. So what we are doing here is that this port is the container port. The port my app is running inside the container, and this port is the port I want to access this my container that is running inside, this my app that's running inside this container. I want to access it in this port, right? I can change it here. I can do, okay, let me use port 503. Let me use 503, right? Now I have this command. Let's finish, add the other things there. Sorry, let me Now, now if you check our application actually need this env to run. And bear in mind that when we create our image, our Docker image, we added the env.env to docker ignore, so that the env file will not be added into our Docker image. So that's the standard practice. That's a better practice, a good practice. So now, now we want to run our application. We need to give it the env file that is going to use to execute. Right? We want to run our image. We need to give it the Docker file to use to execute to run our image. So we're going to do something like hyphen env file. So I'm saying use env file, which is .env, right, in this directory, in this same directory. So when that is done, what again do we need to do? Okay, I can now give it a name. I want to give this container, this our image that is going to be run. I want to call it blog server running. Right. So since I have, so this is the thing here. Blog the docker run command. I give it the name of the name of our image to run. Um, okay, let me confirm. Let me confirm something. If I'm not okay, yeah, the ports are working. So Docker runs. We are running the server. Yeah. All right. So let's. So we are good to go. Let's click enter. Oh, env not found. Let's see. Wow. Okay. I think that name was confusing it. So okay. All right. So let's. Sorry, guys. .env p. Let's change the position. 5,000. Okay. Then the name of the image. Cannot find module. This folder. Okay, so it has to do with our application. Sorry guys, I forgot to build. So in this our application, sorry, I forgot something. We forgot to build the application. So supposed to add something like this. Right? Supposed to add something like this. npm. Sorry. So after installing, we're supposed to add something like this. So we need to. Sorry, let me delete the the former image. Blog server. I want to delete it. Unable to. Oh, so let's, sorry. I want to forcefully remove it. Okay, I've deleted it. So let's recreate it. So since I updated the dockerfile command, I need to update. I need to rebuild the image. All right, this is the command to rebuild it. Let's rebuild. So because why I added this, is because this is a TypeScript project, so you need to build it before you be able to run it, to start it. So that's why I have to enter this command. But if you if it's just a normal JavaScript, Node.js JavaScript project, you don't need to add this build because the application will execute by itself. So let's check I think the Docker image is now. We still have it. Uh, okay, it didn't build. Did not complete successfully. So let's see how I built it here. Okay, I'm forgetting this. npm run build. I think that's even what should have worked here. Sorry guys, this. So please be careful when you are specifying commands like this. I think that's even what's happened here. npm run install. When you want to run command, npm actually, like, you need to specify run your commands so that everything will work. Here I'm even supposed to add something like run here, but let it just build. Okay, you check the GUI here, you can see there's no, that's the blog server is deleted, it's no longer here, but when you finish building you're going to see it, this image. Yeah, it's here now. It has come, just arrived now 11 seconds ago. It got built. All right, so let's run it now. Let's see. Our app is not running. It's still throwing this configuration error, connection error, sorry. So let's run the application. We are running it in port 5003. So let's see. So as you can see, server running on port 5000, right? This is Redis issue, Redis error. So if I come here and update this to, let's try 5000 here, to port 5, because if I leave it at 5000, it's still, we are not accessing port 5000, so it will still throw the error. Or if we do port 5003, see it's trying to execute. Well, I think there will be issue here. Yeah, we got something went wrong. So our server is up, but there's some issues with it. But I just want you to know that we have we can now run our container, right? If you come to containers here, this is the name. It gave us it gave the container a default name. This is the image, right? This is the image. He gave it a default name because we didn't give it a name, so we gave it a default name. So if we see here, it's already running. The image is running. So let's bring it down. Let's stop it. If I come here and do docker stop container, what's the name? The name of the container is sad underscore McLaren. Let's stop it. It stops here. If we check here now, it's no longer running. The green, the highlights is out. Right. So if we check, if we list all the Docker containers, there is no Docker container running. So guys, this is how we build image and run the container out of our image. So I don't know if we have any question now. Why we got this error here is um, because of the Redis configuration we did. All right, because of this Redis configuration. Where is it? This Redis configuration. It was trying to this Redis configuration is inside our laptop, but our application, that block server application, is running inside a container, Docker container. So the our application inside the Docker container was trying to access this, trying to access Redis inside that container, but Redis is not running inside the container, it is running outside our system. That is why we got this error, this server error. All right. So but the main configuration here, if we want our app to be running, we need to also configure Redis to run inside container, so that our application and Redis will run together. All right, inside the container we'll be able to communicate, and we can do that via Docker Compose. All right. I'm going to introduce that to us. But guys, can we go on a break? I want us to go on a break. This is 2:24. So let's come back by 2:40. Right, 2:40. Then I'm going
Mis-
to,
Mr. Christian.
yeah, yeah.
Oh, thank you so much. Maybe when we come back, I will love to ask you questions.
Okay, okay, okay. So if you have any question when we come back, you can ask it. So I want us to look at Docker Compose because it will be the next thing here we're going to talk about. All right, guys. Let's come back by 2:40. Yeah, 2:40. 15 minutes break. right, guys. Let's start. All right. I said we're going to discuss Docker Compose. Um, okay. Basically, um, Docker Compose is just like you have multiple images that your application, should I say, let's say your application, the architecture of your application comprises of multiple images. I will explain what that means. So you need Docker Compose to manage those images, right? So what do I mean? I think I have slides for this. Oh, I didn't pause my recording. So this. All right. So let's. All right. Docker Compose. Why do we need it? Running multiple containers manually is stressful. Docker Compose solves this by defining our service and the rest. So basically, now let me use our application now to illustrate that. So, like guys, we have Redis. We configured Redis inside our application, right? And basic subsequently we configure. We have to use Kafka in our next class. We have to configure Kafka uh, into our application. Basically, what it means is that you have to. I downloaded Redis, right, and I have to download Kafka softwares into this application into my laptop to use it configure it in my application and use, right? Now these softwares, the Redis and Kafka, that I am downloading into my laptop to configure it and use it some application, there are softwares that I can, instead of downloading the code, the software proper, I can either use the image, the Docker image, their Docker image, instead of using the softwares, right? Even this database that we're using here, this our database, MySQL database, we can use their image. We can use their image. How do I know that? Okay, let's go to Docker Hub. Now, Docker Hub here has the Docker images of many applications, right? So if you like, that's why I told us that, okay, if you don't want to, if you can't install Redis in your system, you can just um you don't need to worry as far as you have Docker installed, because you can use the Docker image of those applications, right? So that's what I'm going to show us now. So when you get Docker image of those application, when you have Docker images of those application, instead of the proper image, the normal softwares, where you have the Docker image of those applications, now you add them in your system, you add them inside your application, and you run them. You need the Docker Compose to be able to manage those applications alongside your app, right? Because when you want to, let's say you want to use it now, you need to since you have the image, you need to run the, let's say I have Redis and Kafka I want to use. To start them, I need to run the container of the Redis and run container of Kafka, right? So running those two can be, when you're managing images like that, it can be stressful. It can be straight with here. So you use Docker Compose to run them. And what does Docker Compose help you do? Basically, it helps to start those containers, those images. It helps you to run the containers at a go, and also bring stop them at a go if you want, anytime you want to stop them, right? So I am in Docker Hub. Let me just show us some of these images for these applications. So this is Redis, right? Let me show you this. So this is Redis image, right? I'm going to push our application to our image to my to this Docker hub. You're going to see. So this is Redis. So instead of downloading Redis software, like I told us to download, instead of downloading Redis software, you can choose not to use the software and use the image, right? And this is how you get the. I'm looking for. Now this is how these are the all the tags here. You can pull anyone, right? You can use anyone. We're going to see how we do that, right? So you can use anyone you want to use. There's also MySQL. If you check for MySQL, instead of using normal database, right? Downloading the software, you can decide to use the image, right? The Docker image, and use it in your application, right? Now, no, I don't want to run them. I have them in my system. So these are the images, right? So here now, instead of I have Docker, I have Redis in my app, I have Redis installed in my local host, because let me show you where I downloaded the software. Let me show you where I downloaded the software. This is if I search Redis. Okay, this is it here. I downloaded the MSI file and I installed it, right? So if I don't want to install it, I can just use the image. And how do you use it? I can just if I want to bring the image, like install it, the Docker image in my system, I can just do Docker pull. Then I will look for, this is okay, this is MySQL. I'll look for the distribution I want to use, the tag, the particular one I want to use, Redis. Now, yeah, you can just do Docker pull. So I can just do, if I do Docker pull, it's going to download the image into my system. Then when it downloads, I'll be able to run it. Then when I run it, everything, exactly everything that the software that I downloaded is doing is what the image is going to, the container, Redis container is going to do for me. All right, exactly everything it does is what it's going to do for me. Yeah, I already have it in my system here, Sef, right? I already have the images, Redis image, MySQL image in my system. All right, I already have Kafka here. They're already in my system because I have already put them. I don't want, that's why I don't want to pull it. So since they are here now, I can run their containers and use them as and use them like normal software, like use normal software. Okay, so I am going to show us how we are going to configure Redis in our system right now. So we're going to configure Redis in Compose, in what's it called? Sorry, in Docker Compose. But before we use it in Docker Compose, let's run it in our application. I mean, let's run the image alone, like just start the image. We're going to use okay, so let me list here. So I do Docker image list. Okay, we have blog server, that's our application. Then we have Redis and some other images, right? So we have these images here. Let's see if any container is running. This, what I showed you now, is just image. We need to check if any container is running, that's if any application is active. Okay, no container is running. All right, let me start that Redis container, that Redis image. Sorry, I run docker run the name of, what's the tag? Tag is 7. Right now, the port. Now, our currently here, our Redis is running in this port. The Redis we have in our software that I have in my laptop is running in this port, right? So if I put this port, it's going to collide. The port won't be available because if I check, let me check. Okay, no, I can't see it there. So I need to give it another port. Let me give it 6378, right? Then I will now put this the default port 6379. This 6379 is the default port in the container that if I run this item now, it's going to run in the container, right? But this 6378 is the port that is going to connect to in my local machine, right? Because if I use 79, the Redis I have installed is already using this 79. Right? The Redis I have in my local machine is already using 79. So that's why I don't want to use it. I'm going to use 78. Okay. Hold on, guys. Sorry. Let me confirm something. Right. So so let me give this our Redis a name. Redis running. All right. So if I click enter, okay, I think the positioning, Redis, give it name Redis running. Then give it ports 6378, 6379. Then the name of, right? Okay. Right. So it's starting. It has been initialized. So if we check, let's let's check the container. If we come to this the GUI here, yeah, if you see, it's highlighted that it's running. If we come to container, we're going to see it's here. This is the name I gave it, Redis running. So it's already running. So Redis is running, but the port now is in, it's running in ports. So if I want to use it, in this my application now, if I want to use it in application now, instead of these ports, I'm going to use the 7.8 because that's where I'll be able to access it. Right. So let's, if I run my application npm run. So our blocks server is no longer using the Redis that is installed inside my local machine. It is using the Redis that is running as a Docker container, right? But I am starting my application as normal application now. I am not running it as a Dockerized application. So basically, I'm not running this our Docker our blog server. If I come to this image, I'm not running this blog server. This application as blog server, right? I'm just running it normally. But after this example, I'm going to run our application as a Docker container, then run Redis also as Docker container. Then you see how the two will communicate together. So if I come to Postman here, this error we got here, let's see if we're going to get it. Okay, it's 5,000 now because our application is running 5,000, the normal 5,000. So you see it runs very well, right? Our application is running. If it's caching the if you check this caching now, cache posts is null. If I run it again, it's going to cache the normal way. You're going to see the data it's cached. If I run it again now, you see, let's see. So it cache the application the normal way. So basically, it's the cache the Redis is using now is not the app is not the software Redis. It is the Redis application, the Redis container, Docker container that it's running. All right. So that's why it's here. Because if I change this thing now, if I let's say I just put random ports. If I put random ports, let's say I just put anything here, for example, and I restart this application, we're going to get error. Okay, see our application is restarting. Our application is restarting. You see, you're going to be getting this error here because our application is trying to connect to Redis. You see, it's telling me that is this local this IP address and this port. It's not connecting. It's trying to connect to Redis. It's not connecting, right? If I run this one now, this endpoint, you're going to see that error. That first error we got. Something went wrong. Okay, it's not even returning anything. Just there. So it means our application is now faulty. So okay, if we go back, see it returns that internal error. Something went wrong. It's because Redis is not connecting. So when we run the query in this our code here, it's actually from here. That error is actually from here. That something went wrong error. It's actually from this place here. It's actually being caused from this it's caused by this query because we're trying to access Redis and Redis is not connecting, right? So that's the thing here. So here I'm showing you that our application is no longer using the software the Redis software I installed. Is now using the Redis container that is running. Right. So if I go back to Redis configuration and I remove this to change this to 6378, right, everything is now going to work. Redis is going to now connect. You're not going to see this error again. See everything is running. Server running on port 5000. Now if we call this again, it's going to return data as normal. All right. So guys, this is it. So our application is running and it's using Redis container, right? So if I come here, if I stop this Redis container, this Redis that is running, how do you stop the Redis container? Just Docker, you use Docker stop. Guys, don't worry, these commands are in the code. You're going to see it, Docker, then the name, which is Redis, the name I gave it is Redis running. If I click stop, it's going to stop. It has stopped. So it just console log the name back to me. So if I come here, if I go to container, you're not going to see the Redis running. The Redis running is not highlighted again. It's there. I've not deleted the container, but it's not running. Then our application will stop. We start showing that error. Our application, you see, it has started showing that this connection error. I started showing because Redis has stopped running. Then if I try to get, if I try to get it, try to get post, you're going to see that 500 error. Something went wrong error. Yeah, we're going to see because Redis is no longer running. So guys, that is it now. Let me stop our application. Now, I'm going to delete the container, the blocks, the our container, and this Redis container I created. Then I'll create new containers for them. Then when I do that, you're going to see how we're going to connect our application together so that they will connect, they will see themselves. So now um, to do that, now let's look for the containers, the ones that are not running. So I need to delete this one, and this one. Sorry, let me use the terminal. So this command is to, if you want to list all images, Docker images in your system, this is the command you use, Docker ls, right? It will list all the images. These are images, they are not containers, they are just images you've created, right? They are not containers. Containers is running images. So if you want to check the images, the containers that are running, Docker ps, this one will show you images, containers that are currently running, right? Here we don't have anyone that's currently running because we just stopped the ones we have. Then if you want containers that are not running, they are containers but they are not running, you do docker ps, then -a. -a will show the ones that are not running, and the ones that just show everything that's not running. So we have containers, Docker containers, but they are not running, right? So if you can see, this one exited 2 minutes ago and blah blah blah. So I want to delete these ones. I want to delete them. So I will delete this one. In fact, I'll delete this, anyone that has to do with these images, our block server and Redis. So let me just delete them. Do docker remove is for you want to delete the image. If the container, if you want to delete the image, use rmi, to delete the image. So then you provide either the name or the id, the name of the container or the id, right? So this is the container id, this is the container id tab here. So everything here is container id, right? So that you use the name, the container id, or you use the name, right? So let me use the name. I want to remove the Redis running. See, it's removed. I want to remove the next one, this one called magical chapline. Let me just, let me use the ID of this one because the name is funny. Copy the name. It's removed. I want to remove this one too. Let me copy the name, the ID. So they are removed. If I try to list them again, ps-a, see, it's just these three that it showed. They are not, the others have been deleted, right? So I have deleted the images, the Docker containers, right? So now let's restart the Docker image. Let's recreate the image, the container. Sorry. So I want to recreate the image, the container for Redis. The same thing. Redis. This is the name of the image I want to use. Redis tag 7, and the port 6378 to 6379. Then the name Redis running again. Sorry guys. Let me bring this. So the ports, docker run, the ports mapping, the name I want to give it, and the name of the image I want to run. Now if I don't want to see that those console log, like if I click enter now, you're going to see it's going to be logging or as it's starting the application. If I don't want to see it, I will just use -d. -d means that it will just run and it shouldn't show me the logs. So if I click enter here, okay, the positioning of the argument, let me put this -d here. Is already in use by container. Okay, the name is complaining about this name. Let me call it Redis run. Okay, it started now. So our Redis container is running. So now guys, since I'm going to start our container, our image. I'm going to create a new our application. I'm going to create a new image of it and run the Docker of the Docker container of it. So while I am doing that, I want our our app to connect to this our Redis container now that is running. All right, I want our app to connect to this Redis container now that is running. So since I want it to connect, I'm going to do something here. I'm going to give it this host here. I'm going to change this host name to the name of Redis that I use here, which is Redis-run. So I'm going to use this name here, right? Now, I am not going to use these ports here, because the container, right? Okay, let's use these ports. Okay, now let's use this one. All right, so I am using the name of the Redis, and I'm using the port. Instead of using the port now that is inside my local machine, I'm using the port inside the Redis container. So our application now that is inside the container will now be able to communicate with the Redis that is inside the container that is running. All right. So since this is done now, I'm going to delete this image. This first image I created, this our blog server image. I'm going to delete it and recreate another one. Remove blog server. Wait, let me first console log so that you guys will see it. Oh, sorry. I hope. All right. So this is it. This is how the image. I want to delete this one. So if I do docker remove blog server, that's deleted it. And it's so if I console log it again now, if I log it, we're not going to see it here. It's no longer here. All right. So let's recreate it. I'm going to do docker build. Right, what was that command? Let's check the command to build. right. So we're going to tag it blog app. Let's call it blog app this time. Let's give it version 0.0.1. Then what else again? Then the dots. So this is it. So we're going to see how this will relate. We're going to build. So we are rebuilding it now. So it's building. We check our. If we come back here to check our images, it's going to reflect here when we build, when it's finished building. Okay, so guys, after this, we're going to see how the Docker Compose. Basically, Docker Compose is kind of straightforward. We don't need much item for it. So it's building the application right now. Then when it's done, we'll test and see. After it finished building, we'll now run the application. So let's see if it's not, it has not been created. It's not created yet. Guys, I hope you are following. Is the whole topic too um is it too confusing or complex? Hello guys. Is the whole topic too confusing? All right. Okay, exporting. So after this whole thing, we're going to push our image. Okay, so it's built. Our image has been created. So look at it, a blog app, and this is the tag I gave it. That's v0.01. So this is it. Our image is here. So, but it's not. There's no container here. We haven't created container of it. Let me delete all these containers here. I thought I've deleted this container. Let me list it. Let me see if I have PS. Okay. Let's remove this container. Okay, yeah, that one is sorry. Let's delete these containers. I don't want to see them. Remove. Okay. Let's remove, delete this. Deleted. Let's delete this. Deleted. So if we do docker ps, and let's okay. Okay, let's stop this one. That is, let's delete. Let's delete this docker Redis running. All right. So we only have one docker image, which is the Redis run image, and it is the image. It is the container. I mean, we will have one container, which is this, and it's what it's running. So all right, so this is the only image, docker image we have now, docker container that we have that is running. So let's create docker container with this our docker image, blog app image, right? Let's do that. So docker run. Okay. The name of the image is app, blog app, which is v 0.0.01. Then I want to give it a name of blog server. Then let's map the ports. 5 let me use 5003, or let me use 5002 to 5000. That's I'm going to access the container in my machine, in my local machine, at port 5002. So we are going to name it this, and this is okay. All right, if I do let's click enter. So it's now running. All right, so we are getting this. Okay, I think this port will be accessed from here. Let's stop this and remove it so that we can rebuild our. Oh, sorry guys. This topic is kind of. It has to do with practice. If you are new, if Docker is new to you now, it may be confusing. Please, maybe after today, you can just go through the video once more. It's actually straightforward, but it may for the first time it may confuse, like may be confusing to you. But with practice, with everything, you're going to scale through it. All right, if you have any question you can ask me. So when we've done with this, I'm going to show us the Docker Compose file, but I just want to show us how these two containers, our application container and the Redis container, are going to communicate, run together. So I have recreated the image, our blog app image. So okay, let me delete this thing. Sorry guys. Okay, so let's rebuild. Let's rerun our application. It's going to be blog app with version 0.0.1. Then let's give it a name. It's going to blog server. Do port mapping of 502 to 5000. I think good, run it. Okay, it's running. It's starting to run. So it's running. Oh, okay. So I think this connection was okay. I'll need to create the connection. So guys, let's have a look at Docker Compose, the configuration file. Then maybe we'll deduce the connection from here. All right. So This is how a Docker Compose file looks like. Let me see if I have it in my slides here. All right. So this is Docker Compose. Okay, this is the command. Okay, this is the file here. So when you look see Docker Compose, you're going to see it looks, this is the default look, right? You have the version number, then you have services is kind of important. This is where you see services is the different containers that you want to run, like you want to manage together. That's what the services are. All right, then you have the app, you have the DB, for example. So the app, we will build the app, the build this, this is service app. Then build is like we are building this app from the default. See this dot here, it means that the Docker file that you Docker Compose is going to use to build this app service or app container or app image is located in the default, like in the current directory. Then this is the port mapping. It's just like that our Docker command that we used to run, Docker build and the rest. So you have the ports. Then see this logic here, this keyword here, depends underscore on DB. So, and if you see this DB is what is mentioned here is this DB here. So this DB is it's an image, like it's an image. They're pulling, they're supposed to put the image, which is my MySQL database image, right? Why this application is being built from the from the application. It's from the like you the sub the app, maybe your Node.js application you created is being built from here. But this DB image, this DB service here container is being pulled from an image, right? Which MySQL. So that's the difference. Then the environment, you can specify some environmental variables for the database or for the service. You can even specify environmental variable for this application, for this app here. Then volumes. Now let's discuss volumes. I think I have the slides here. Yes, let's discuss volumes. Now, okay, let's discuss volumes first. Now, applications like database and Redis, they has to do with storing of data. Like database will store your data, right? Then Redis also, we are storing those cache information, those cache data, right? We're storing those cache data. So these applications are called stateful applications. Like they have data they store, right? They have data they store on the machine when you install them, right? So, but this one thing about Docker and the Docker containers is that when you are running the Docker container, the application, the software is running, the Docker container is running. If you stop that Docker container, everything about the Docker, the data it stores, everything is going to be wiped out. It's going to be deleted, right? So if you are using in this configuration now, if we since we, if you are using database container, right, database container, you are using it the database image you're running as a container for your application.
Christian,
Yeah.
I was saying that maybe you can send us this document.
Okay. Yeah. Like I should send it now. Okay. Let me see if I can add it to the
Uh,
group.
Not now, maybe later, even in the group or in the message section.
No, of course.
I see. Think I think it will be good if you send in the group.
Yeah, of course. I'll send it in the group, and also I'll add it to our that repository I created for the course. Everything will be there.
Okay.
Yeah. So for stateful containers that way, when you stop the application, the Docker container from running, like when you stop it, like I used to stop the applications, those data will be wiped out. If you are using database the container, they'll be wiped out, right? So, but to persist the data, like to make sure that the data are not wiped out, like you need to use Docker, what we call volumes. You need to put volumes, like you connect a particular folder on your machine to the Docker container. You link them up so that every data that the container is storing it will be stored on your machine, right? So we use the concept of volumes in Docker. So like the slide says here, used to persist data, especially for databases, right? So you can use this command to create volume just do -v. If you want to run your container and you want to maintain, do specify volume, you use a -v. Then you specified in your you specified a directory that you want everything to be stored. Here, in my application, I want to store all the data in my data directory, right? In where I'm running the command, I want to store everything in my data directory. And you see here, you see there's this colon here. There's this colon. This is local your local machine mapping to the container mapping, right? So you are mapping. You are saying that everything that is inside this the directory of your container. You know your containers are usually Linux servers, Linux operating system. So in Linux operating system, you have the var the var directory, and you have the lib directory inside the var directory, and you have the MySQL. So when you install MySQL server, MySQL system inside the Linux environment, so it's going to be stored. Most of the directory is going to be stored in this part here. So that's why we are mapping. We're saying that all the data the MySQL is going to store should be mapped to our my data here. So when you start using that container as your database, the data that's going to be stored, that is going to store, you're going to see it inside this directory here. So why that is important is that anytime if you destroy that container, right, if you stop that container, the data will not be destroyed. The data will be here. It will be in this your directory here that you specified for volume, right? So when you start the container again, it's going to pick up all the data. Is going to pick up all the data that it left here and pick it up and start using it. So this is what we call persistent data using volume, right? So that is for volume. Then this is more port. I've been showing you guys more port mapping. This is how we do port mapping here. So here we are trying to run Docker, and we specify ports here. So this is the host port. This 8080 is the port I can be able to access this application in my machine, right? Then this 5000 is the port the application is running inside the Docker container. So basically that's just the two things. So when you see mappings like this, like mappings are being separated with colon, this colon here. So when you see mappings like this, the one in your at your left hand side is the host, while the one at your right hand side is basically the container, right? So you are trying to connect the two together. That's okay. I'll be able to access what is happening in the container from this particular port. So so coming back here, this is our compose file. So let me show us our compose file that we're going to use for our project. I have two compose file here, right? One for dev and one for production. So what's the difference between the two of them? This one for dev has our application. We not dockerize the app like this application in this dev one. We did not dockerize it. And how do you know the file here? How do you know it's a Docker Compose file? Docker Compose file is usually the extension is .yml. Sorry, it's either YML or YAML, YAM file, right? .yam file. So you can give it any name, right? But the convention is you name it docker-compose .yml or YAML, right? So I have two of them, and that's why I have to differentiate them by using a docker-compose.dev.yml. Then the other one is docker-compose.prod.yml. So this one I want to use it for development, and this one I want to use it for production, right? What's the difference now? The difference is that this one on this dev one, I did not dockerize the application. This application we are building, I did not dockerize it because I want, as I'm writing my code, I want the changes I'm making to reflect immediately. While for the production one, I dockerize the application. This application, I dockerize it because I need my application to run as a Docker container. All right. So if I decide to dockerize the development one, it means that anytime I make correction to my application, I need to come down. I need to come and to see the changes. I need to restart the application. I need to rebuild the application and rerun the container, which should be too much work. All right, that's why I did not containerize it on the Docker Compose for dev, but for the production it is containerized. So let's go through the folder. Let's go through the content of the compose and see what it's actually saying and how we're going to use it. So for the dev one, this is the, like I told you guys, you have from here, from the slides there, you have the version, but this version now is obsolete, it's deprecated. You don't need to specify version when you are creating your Docker config, your Docker compose. You just use start from the services and you start naming, right? So here, as this is from services, right? Services that will come down, you specify this first service, which is Redis, right? The image is Redis -7, like I've used to start the Redis application, which is the image. This is the image version we are specifying Redis, comma 7. I mean, I say :7, Redis :7. That's what it means. Redis :7. That's the name colon the tag. Then container name, I want to give it a name when it's running, so I give it a name, Redis, simple, right? Restarts. Now this is very important. When you are running your container, I think I supposed to mention it. When you want to start your container, you need to specify restart logic to be always, because you need your application, your container to be, anytime this, if the system shuts down and starts up again, you need your container to start up by itself immediately, right? So you need to give it this flag here. If you are using the Docker command line, you need this flag, or you specified it in this Docker compose. Restart is always, restart is a keyword, you give it always. There's some other type of restarting, maybe I think is it I don't know, I can't remember the other ones. I always use red always. So then the port here, ports, just the way I used to do port mapping. This ports I do here 6379 6379 is the same thing you're seeing here, right? In the compose Docker compose file, ports here, this is port mapping. Now volumes. Now what we are saying here now in this configuration, I was saying that in this application, we'll create a folder called volumes, and dev, another subfolder called Redis, another subfolder called Redis underscore data. So that's in this directory. We want to map it to Redis, to the directory of Redis, the data directory inside the Redis container, right? So we're going to map. So this is where Redis stores all those cache data. Those data it is caching inside this folder, and this is where inside the container. This folder inside the container, that is where it's going to store it. So we want to map it into this folder, into this our folder here. So when we start up this application, you're going to see a folder called volumes here, if it's not already here self. Then that is it. Then command, this is the command to start up Redis, right? So when you want to start Redis, you use this command to start up the server. So this is the command you use to start up Redis. This is the same command that this same command here, just for application. If you are adding our server, our own server here, is this is the command. Okay, no, the command is already in the build, but okay, this command. Where's Docker? Alright, this command here, that's what we specified in the compose here. But for our application, we don't need to, if we configure our application, we don't need to specify commands here, because since we are building it from our file here, our Docker file, so the command is already in our Docker file, so it's going to be executed from there. So this is for Redis. This is for Kafka, right? This is for Kafka configuration. This will handle this one next week, but let me just explain. It's almost the same thing. It's almost the same thing. So this is Zookeeper. We use Zookeeper and Kafka together, right? They come hand in hand. We use them together. So basically, it's just the same thing, the same configuration here. The image is the same thing. The container name is the same thing. The restart logic, restart command is the same thing. The ports also, you give me the ports. Then volumes too. They have their own volumes. Here they have this one. How the zoo have double volumes, right? The same thing with Kafka, double volumes. Then we have the environment variable that we want to pass along into them here. But for Redis, we don't have any environment variable that we want to pass to them. So how do we now use this file? This file. Let me show us. Before then, let me see if there's any container that's running. Containers that are running. Let's stop them. Redis. Let's remove them. Let's delete them. So let's see if there's any one that is not running. Okay, let's remove blog server. I don't want anyone. All right, so let's see the image. What we have in image. Let's delete. Let's remove the blog app. Okay, no. V 0.1. All right, so all right, our system is clean. All right, so I've removed containers and this any conflicting image. So now how do we, so this file docker compose will now, with this file docker compose will help us to manage all these containers here, these images here. The image container is going to help us start it everything at once, then help us shut down everything at once when we want. So what's the command? You just do docker compose, right? We add compose, right? In the other commands we are not using compose, right? So docker compose. What next? I want docker compose to use this file. If I don't specify a file, docker compose will be looking for a file called docker. I think it will be looking for a file called docker compose dot this file. It will be looking for a file like this. If I don't specify a file, and we don't have it, we only have the ones for production dev, right? So because I want to, let me specify the file it's going to use. I want it to use docker compose dot the dev one yml. All right, now what's the next command? I just do up. Docker compose up means start. It should start up every service that is specified inside the docker compose file, right? This is it. If I just click enter, it's going to start up every applications for us. See, starting. Right, now attaching Kafka, Redis, Zookeeper. So it's now running. So it automatically created network for us. So here now, Docker Kafka is running, Redis is running, but it's Redis we pay attention to. So if I come back here and do Docker PS, you're going to see all these service that are running. Redis is running, Kafka is running. Kafka is because we added it into the system. So Redis is running. All right. So our application now can now use Redis. If I come here and change this to Redis, oh no, let me use this one. I use this. Let's see. Right. So if we start our application, npm run dev, everything is going to start up now. Let's wait for it to start up. Right, our server is now running for 5,000. So if we go to our postman, if we call our postman, so everything is running normal now. All right, so our application is using Docker, is using Redis. I mean, right, it's using Redis. If I call Redis again, if I call the post again, you're going to see it's logged already. So our application is using Redis from this container, the container Redis. It's using this uh, container Redis here. All right, so this is this is the name. Okay, this is the all right, and guys, look at this folder here. Like I told us, this is the volume. Now Redis is this is the volume Redis is attaching. Like if we check this Redis service here, this volume here is this here. So if we open the volume, this is it. Inside the volumes directory, we have the dev directory, which is this dev directory. If you open the dev directory, there is Redis, there's Kafka. This is the Redis directory here. This is this. So you see some data in it. So these are the data, the cache data that Redis is caching on our system, right? So this is the volume here. So if we stop this, if we stop this Docker, the Redis Docker and everything, this volume are still going to remain with us, still going to remain in the application. So it's persist. So we can actually map the volume to some other folder that if we want. All right. But for production, we don't want to map volumes to our production. On production, if you check the production file here, the volumes here we use what we call named volume for production, right? If you see here, we gave it, just gave it a name, Redis data, and we map it to the normal Redis container folder. The same thing for Kafka here also. We just give it a name, data and secret. Now, if we come down here, we now these names that we gave them, we define them here, right? We wrote volumes and define them here. So we gave just these are conventions, right? Now this name is, you can use any name, but this driver item is convention. Now what it means is that we want Docker to manage the volumes for us. We don't want to map it into our application just like we did for dev, that we are storing everything inside volumes data, inside volumes folder. Here Docker will manage everything. Docker Compose will manage the volumes for us. You know, we store the volume where it's supposed to store it in our server and everything. We don't have to worry about where it's storing it. Okay, so guys, this is this about Docker. Docker is very easy. It's very um, easy to use, and if you see now, if this thing is running, if I leave this application to be running this way, right? If I put off my laptop and put it on again, automatically these containers will start up. If I put off my application, okay, so these are the containers here, the Kafka, the Redis, and the Zookeeper. These are the containers. So if I put off my laptop and bring it up, right, and put it on again, the when immediately Docker starts up, because Docker is supposed to start up, immediately Docker starts up, it's going to start up all these containers, right? And why will it do that? It's going to do that because we specified restart to be always. Because of this command here, restart always, restart will be always. So anytime Docker comes off, it starts off every containers that has this configuration of restart always. So by so doing, if you deploy your application to the cloud, anytime the cloud shuts down and comes up back, your applications will start up immediately. And with that, you have like low downtime of your applications. Right. So guys, this is the container. If you have any this is Docker Compose. If you have any question, you can ask me. If you don't understand anything, you are free to ask me. Hello guys, question, any, if you have any question, shoot. Do you understand everything I explained?
Hello, Christian.
Yes, boss.
I wanted to ask a question between Docker image and Docker container.
Yeah.
Maybe a summary difference between the two, because I can see they're almost working the
Okay.
same way.
You build a Docker image, and you run a Docker container from the image. When you first build your Docker image, then after building the Docker image, you now need to run the Docker image, like make your Docker image. Docker image is just like your application. It's still your application that you've created. It's your application that you've created. You Dockerize it. Now, when you do that, when you want to run that your application that you have Dockerized, when you want to use Docker to run it, you when you do that, you're actually running a Docker container. It will run as a container, so we'll call it Docker container. Do you understand? So you just
Okay,
like,
so the first step is to just build, because we can't run a Docker image. So we create the Docker image first, then we run the Docker container.
yes, yes. So let me now that I've finished with everything, let me just show you the simple steps, right? Let me show you the simple steps now. Hope you can see my screen, right?
Yes,
Good, good. All right. So this is my application. This is our application, right?
yes,
Now, if I tell you Dockerize this application, right? Forget about all these things that are here now. If I tell you Dockerize this application, what you do, the first thing you do is you will create a Docker file. This Docker file, you just come here, create Docker file, no extension, right? You just come and you do in that your application, you just do Docker file. When you create it, right? You have created it, right?
yes,
Now
yes,
in that your Docker file, you now come and you see these things here.
yes,
Yes, these are the steps to create a Docker image, to build a Docker image, right? You see this from
yes,
work directory, work, copy, and the rest. When if you are building a Node project, you use Node. If you are building a Python project, you use Python. And Python project has its own specification, but the commands here will be the same. This from, this work directory, copy, run, copy, and everything will be the same. They are specific to Docker. They are specific to Docker. They are commands for Docker. So you now write this command inside that Docker file. So when you finish this command inside the Docker file, you have Dockerized that application. You have Dockerized the application. Now, to
Okay.
build the Docker image, to build the, because after you finish you have Dockerized, then you need to build the image, right? You need to build the image. Now, how do you build it? You use the command. I'll still come to this, what these things means, right? I will still come to them. So you use the command docker build, right? Docker build. Now you need to give the image a name so that when you push it to Docker Hub, or you want to give it to somebody, they will know the name they were going to use to access it. You need to give it a name, right? So you use -t with space. There you write the name. You can just so say blog image, right? Then
Yes.
you can tag it. Tagging means like what version, just like what you are seeing here. This is an image. This node, this thing you are seeing here, 20 hyper is an image. The name of the image is 20, and they tag it 20. The name of the image, sorry, is node, and they tagged it 20 hyphen hyphen, right? You can do the same thing
Yes.
here. We can do blog and tag it, give our own blog and do 20 hyphen and do anything like Linux. All right, this is the same thing they did for them, but this is our own. All right.
Okay.
Then when you do this, right? Let me
Yes.
just give it a latest, for example. Then you now put dots. You see these dots here? I put at the end. The command is complete now. So what I'm saying, this dot means that the Docker file is inside this directory. The same this directory, right? Then when I click enter, right? If you click enter, it's going to build. Let me try it now. We're going to see this image. Now it's building it, right? So we have completely dockerized. If this finished building, right, we have completely dockerized this image. Then we'll have this application. Then we'll have this thing here as our Docker image, right? Let's watch and see.
What does the hyphen T means?
Hyphen T means tag. It's just tag. You are tagging
What?
the image.
Okay.
Yeah, tagging the image, it means giving it a name and a version.
Okay.
Yeah, you tag, when they say tag an image, you are giving it a name and a version, right? So when it finish building, we are going to see the image. We have not created container yet. It's just the image of the application. So we're going to see that blog app here. It's going to appear here as image. Now, when it's finished building, you just created the image. Now that image, you can give it to anybody. You can deploy it to server. That image is your whole application now. Is a file, just like you zip this file, this your project, you zipped it and send it to somebody, or you zipped it and kept it somewhere. That's basically what the image is. Yes, it has finished building. Let's come here.
Okay. So when I send the image to someone else, the application will just run fine.
Yes, hold on. I will come to that. Now we have built the file now. It's just like we have zipped our file into with Docker. We have zipped it. Now, if we can take this image and give to somebody, now how the person, when if the person receive it, how is the person going to use it? It's just the image. You've not how are you going to use it? The next thing is you run it. You run the image. It is when you run the image you get a container.
Okay.
Yes. So let's this image now that we've created, this blog app that of latest of tag latest. What do we do with it now? We run it. And how do we run it? You know, the first one we use Docker build. Here we use Docker build. Yeah. The next
Yes.
one we're going to use Docker
Um,
run. Right? Now,
yes.
now we want to. It means we want to execute that Docker image, and doing that, we need to specify. We need to specify the port mapping. That is, if this Docker is running, if the Docker this Docker image starts running, it's going to run in an isolated container, Docker container. It's going to run isolated Docker container. It means you won't be able to access it from your local machine, right? You won't be able to access it from local machine. But we need to do a port mapping. We need to connect it. We need to be able to connect it from our local machine. And how do you do that? Your application is running, will be running inside the port because yes, your application will be running inside the port. In our application, we are using port 5000 to run it, right? So we'll now say if our application is running inside the container on port 5000, I want to be able to access it here in my local machine as port 5000. If I don't do that, I won't be able to access it. So how do you do that?
Okay.
You use hyphen p, right? Wait, before I do the port mapping. Now this Docker run, I will put my Docker image name. My Docker image name is this latest. That's what we built it with. If you remember, this is the build command. This is the tag we
Yes. Yes.
gave it. Yeah. So if we continue, I want to run. It means I want to Docker run. This is the name of the image I want to run. Right. Then let's do the port mapping before it. Hyphen p. Then we put the port mapping. Right. So this port map is saying this right hand side of the port of this colon is the port the application is running. You know, the port I specified in my application to run inside the container. All right, so it's running at port 5000 inside the container, but this port is the port I want to access it in my local machine, right? So this port I can use anything. I can use 4005 to access it. I can choose any port I want. I can use 3000 to access it, right? But this port here must be the port you are actually running your application. You can't, if you use 4000 here, your app is not running in port 4000. Your application is running in port 5000. So you must use that port you are running in, right? Because if you check our application here, if you check our server here, our port is port 5000. Come here, our port is 5000, right?
Yes.
Yes, so we need to use the port 5000, right? But here, the left hand side is our local machine where we want to access it from. We can still access it from the same 5000. All good, right? So when this is done, if I click enter, so anybody we give this our image, Docker image to use, must run the command this way. Like you need to run the command. This is Docker run the name of the image, then you specify the port mapping, right? So is it clear?
Yes.
Is it clear?
Yes.
So this image I created, if I want you to use it now, I will need to push it to Docker Hub, which we are going to do now. We're going to deploy it to Docker Hub. So when you deploy it to Docker Hub, you can now tell your friend that, oh my friend, I built this application. Please go to Docker Hub, pull the image and run it in your system. Right? So if the person pulls the image, they can be able to run it using this command, using Docker run command and the name of the image, and they will specify the ports you use. They will ask you which port is it running on. You say port 5000. Okay, they will now use port 5000 here, but they can now specify any other ports they have in their, like they can specify in this left hand side. They can specify any ports they want. So is it? Do you understand it now?
Yes, I understand it.
Okay. So guys, let's push our Docker image, right? This our application, the Docker image we created. Let's let's push it to Docker Hub. So this blog app, let's push it to Docker Hub. Now, how do we do that? So I have, if you have an account, if you can log in, just go to Docker Hub, sign up, sign up. Let's continue. Let's. These are the some images I pushed some years back. I was playing with Docker Hub, right? So let's push this our Docker. This see the image we created here, the image blog app we created here, right? Let's deploy it. So how do I do that? You first log in. You do Docker login. You do this Docker login. Docker will try to log you in. So to log in, Docker login. So Docker will tell you to open this. Tell you to open this in your browser, and they will give you this code, right? So I will let me open this in my browser. It's opening. It's opening, right? So let me copy that command. That this key, this code here. If I copy the key, the code, come to my browser. You should have logged into your Docker in your browser, like login, sign in. So congratulations, you are all set. Your device is now connected. So we are now connected. So I'll wait here. You're going to see a message. Yeah, login succeeded. So we have logged into our we are logged into our we are logged into our Docker accounts in our terminal. So what is the next thing to do? We need to tag our image. Tag our image again. So we're going to use Docker tag the I want to deploy this is the image I want to I want to deploy. I want to push to Docker this image, right? This is the image blog app I want to deploy. Now my username in Docker here, if we go back, my username is OKK Christian, one word, join together, OKK Christian, right? So I'm going to use it. I'm going to type OKK Christian, then slash. What tag do I want to give this image now for it to be on, like, for it to be on Docker Hub, like the name I want people to access it from Docker Hub. Still, I want to give it blog app, then I want to give it version 0.0.0.1, right? So I am tagging this one, this my app here, this image here that I created locally, right? I want to target this in Docker Hub, right? So if I finish doing this, I will click enter. Yeah, it has been tagged, right? If I do Docker, if I try to list all the image I have now, I'm going to see that new image. So this is the new image now. This is it. That it's just like I created a copy of this one here, right? This is it. Created a copy. So now I'm going to push this one that I just created now. This one. I'm going to push it, right? So how do I push it? Just do Docker push. All right, Docker push. Let me put that v 0.0.1, right? Just the same way I did it first time. Then let's see, look at all the things I have here, all the images I have here. You can see there's no blog app here. There's no blog app here. Right. So if I click enter, let's watch. See, it's preparing it. It's trying to preparing, pushing it. It's pushed some. So it's pushing. It's going to take a little time. It's going to take a little time. Let me refresh and see if it's already here. Okay, it's still coming. Okay, it has pushed. Let's refresh. Yeah, it's now here, guys. So this is it. Okay, Christian slash blog app plus push less than a minute ago, public and everything. Right. So if I click it, let's go inside and see. So this is it. If yeah, this is it here. If we click see all, so if you want to use this image now, if you want to use this image, you can just do docker pull. Let me share the command with us. You can just pull it and you see the image. So if you want to run this our application, your system, you can just pull this one, the image I created, and use docker run. So let me pull it. Let me pull it in our system now, in our, although it's already in our data in our application. Let me delete. Hold on, if I do image list, if I list it. Right, let me delete it. I will need to delete it so that I can pull it from the Docker Hub. So let me delete that one. What's the ID? Use the ID. The name is all right. Yes, use the ID. Docker RMI, then the ID. If I do that, it's error, unable to delete multiple repositories. To delete. Okay, let's see if okay, so you can pull it. I think you can put the image, but if I want to run it, let me run it instead of pulling it. Let me run it. The image is okay. Image okay. Christian. The tag is 0.0.1. So I want to run it. Port mapping 5000 to 5000. Let me use 5001. We don't need to specify. Alright, so if I click enter, let's see. Right, so it's running. I'm running that particular image. Right, it's running, server running port 5000, but it's having issue with Redis. So but that's not an issue, just for us to understand that This is how we run the image. We run the image, yeah, as a container. So I'll look for a way to fix this Redis connection. So guys, this is it. I'll call it. We'll call it a day. I don't know. Does anybody still have any question? Anything? Are we good? All right, guys. Thank you for coming around today. Have a lovely weekend. By next week, we'll be dealing with Kafka. Next week will be our final week. Next week will be our final week, and guys, bear in mind, I'm going to give us a project assignment. I'm going to give us a project assignment. We're going to build something using the technologies we have discussed. Like I'm going to give us something to build. It's not going to be like just for us to learn, right? We'll build it, but it will be after this 6 week. After next week, then I'll just tell us what we can just work on. Then we'll create a. I'll ask you have to create a GitHub repo. You when you finish building, you deploy. You push it to GitHub repo. I may even appreciate here. You also have to dockerize it and push it to Docker Hub. Then you share those. You share the information so that I can access them and see and just we'll have a discussion around it. Right, it's just for us to familiarize ourselves with all these things. These are technologies, and you need to just work with them to finally get them how they work, right? So that is it. That's that. And if you're able to follow through, honestly, if you're able to follow through these technologies, you'll be very confident. You'll be a very confident backend engineer. Like you can do things, you can build things. If they say optimize your application, you know what to do. You know what to do. If you have optimized your queries, the next thing you say, okay, let me cache this system, right? Or okay, you put everything in you dockerize it, and you know you can run multiple instances of Docker, right? So or you can, if they say okay, we want these endpoints to accept large volume of data, you can add Kafka to it, right? You know, these things are technology that helps you to build, to optimize your applications and make you confident as a backend developer. So next week we'll go into Docker, I mean into Kafka, then now this application will now convert it to Nest.js. So all these applications is they are on Express, will now convert it to Nest.js, and we'll see how it looks in Nest.js. Basically the same thing, right? The way I structure the code, I structure it. I was mirroring Nest.js, to be honest. I was mirroring Nest.js using this class, the class styling and everything. Was basically mirroring Nest.js. So when we put everything in Nest.js, you're going to see that it's almost similar. There's not much difference there. Right. So thank you guys for today. Have a lovely weekend. See you next week. God bless you. Thank you. Does anybody have any question? If you have a question, you can ask. All right. Thank you guys.
Thank you so much, Mr. Christian.
Yeah. You're welcome. Do you
So
have any
about
question?
this Docker of a thing,
Yeah. 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 I'm listening. Go ahead.
can you hear me, sir? Yeah.
I can hear
So
you.
about this Docker of a thing, like when you are talking about the port mapping,
Yeah.
can you hear me?
Yes, I can hear you.
So like let's say you want to build your applications, you first build your front end, then build your back end. How do you allow two of them to like how do you connect two of them together in a
Okay.
in a Docker environment?
Okay. So
Like both of them are running, let's say both of them are running on the same Docker, but you
yeah.
have built they have different images and containers together.
Okay.
Yes.
So you will use Docker
So like
Compose.
how do you connect?
Yeah, you use Docker
Okay.
Compose, right? Docker Compose will help you to manage them, manage them as it is. So let me share my screen. Okay, you are still seeing my screen, right?
Yeah, yeah, I can see it. Yeah.
Okay, let me go back to the Docker Compose. So let's assume this is the application, the Docker Compose for the application, right? So this is, let's say I have, this is the back end, and I have the same thing for the front end, right? Everything
Okay,
you just configure everything here the way, just the way they are. Then if they should be in the
okay,
same now the structure you use now um is going to be like, okay, here, if you want to, here we are building the image. Here in this configuration now for the server, we are building the image. Let's start from the building, like building of the image. We are building the image
okay.
from a Docker file from this current directory, right? Now, it
Yes, sir.
where is your front end? Is your front end in the same? You now ask yourself, where is your front end? Is it in the same directory
Yeah.
with where, like, are they in the same directory, right? So if they are,
No, no, I think let's say your front end. Okay.
go ahead, go ahead. Let me hear.
Okay. So, oh, sorry, no, continue. I'm hearing you.
Okay.
I
If
thought you were asking me a question if they are the same directory.
okay, yeah, yeah. Let me see. Are they in the same? Do you? What's your method like? Is it in the same directory or different directory?
No, what's like what I was asking, if let's say you have folder that has a front end and back end,
Okay,
that you
okay,
build them separately, but they are dependent on each other.
okay, okay, okay. Now
So,
I get you.
but if you want to build it yes, okay,
Okay, so this is the picture. If you are deploying them on different servers, right? If you are deploying them on different, like you create a server and you deploy your front end, you create another server and deploy on your back end, then you need to Dockerize them separately.
yes,
You need to Dockerize them like your front end. If you go to your front end application, you create the Docker file, right? Then you put in the
yes,
the Docker configurations. You leave it there.
yes,
Then your backend, the same thing. You create Docker file and everything. You leave it there, right? Now, to connect the front end, the back end to the front end. Now, it depends on the, if you know the domain that you want to host your backend.
yeah, yeah, yeah,
You
okay,
now put the domain, like you put the domain, like my backend will be www.backend.app.com, for example. You put it in your front
yes,
end.
yes,
Yeah, you put it in your front end. Then you deploy the two, like you deploy the two applications to their respective servers. Now, those respective servers, they will have Docker inside them. Then you now use Docker
okay,
to run them. You run it. You run the block server,
okay,
the backend server in its own server. You
okay,
use Docker to run it. Then the front end, you also use Docker to run the front end, right?
okay,
In its own server. Now, when this backend starts running, it will be running. Then the front end will be running on their own separate servers, right? Then
yes, sir,
the backend will be able to connect to the front end. The front end will be able to connect to the backend via the domain. Because when you deploy your server, you must configure a domain so that people can be able to access
yes,
it. Yeah,
yes,
yeah, the
yes.
same thing the front end
Using
also.
yes, right?
Yeah,
I say using the Nginx, right?
yeah,
Nginx
using
Postgres.
Nginx, yes, using Nginx, and
Okay.
you do the DNS
Plus
configurations and
from okay.
yeah. So now when they connect, you can now start. So they are separate servers on separate. They are separate servers operating separately, right? That's just it.
Yeah.
But if they are in the same application, just like in the same system, just like if you want to host the two in the same server, you want to,
VPS.
yeah, in this, yes, in the same VPS. Good. That means you have to create a compose Docker compose for them, right?
Okay.
Because you want to use one Docker engine to run the two of them, front end and back end. You create Docker compose.
Yes, yes.
Yes, you create Docker compose for them. They will have the front end will have its own ports, like port 3000. Then the back end will have its own port 5000, right?
But yes, sir. Yes, sir.
Yes. So when you've created it, it will be something like this. It will be something like this. Here we have the Express app. Then here maybe down below you have the front end, right? You have the front end. Now
Okay.
we now come to individually now on the back end, for the back end, you just do the context. You know where the file Docker file is direct is hosted is like is with respect to the Docker compose file you're creating, right? So maybe in
Yes, sir.
you create a huge folder. For example, you may create a huge folder, right? A huge directory, then put front end and back end inside that same directory. Then when you've done that,
Mm,
you can now your Docker compose will be like wait, hold on, let me do let me although personally I have not deployed application like that, like putting everything inside one server. I do it separately, but let me advise.
okay.
So let me just
I've done, sorry sir, sorry for cutting you off.
no, no
I've
problem.
done something like that. I deployed one app, Express app,
Yeah,
that contains both backend
yeah,
and
it's
front
yeah,
end.
yeah,
So while I use MongoDB as my database, which is the MongoDB Atlas,
yeah, yeah.
so which is sitting on different server,
Server, yeah,
but the front end and the back end, they are on the same server,
yeah,
just
same
that they
server.
are different folder. Yes,
Yes.
on the same server.
So
So I configured them in such a way that they communicate using the port, just as you said.
yes, okay,
So
okay,
now I'm trying to optimize the app using I'm trying to optimize the app because I didn't use Docker or
okay,
GitHub Bash CID, CD and CID pipeline. I didn't use it,
okay,
but I want to like optimize the app such way that if I make any changes, instead of manually going to the VPS to pull the changes and all that. So like what I'm trying to ask now is how do I
okay,
configure the app using
okay.
Docker?
Docker. All right. So we'll
Mm,
discuss the Docker now. Then maybe later, maybe next week we'll also do some small GitHub Actions configurations.
oh, it's okay. All right, sir. All
So
right.
so
Thank you,
if
sir.
if if I am working on that your kind of project now, let's say this is
Yes,
the
sir.
project. This is the project. If I go in
Yeah.
and let's say this is the front end
Okay.
and we have the back end.
Exactly. That's how I structured the.
Yeah. So let me open it in VS Code. Let me open the project in VS Code. All right. So the backend we have Docker file,
Okay.
right? The
Okay.
front
Okay.
end we have its own Docker
Docker
file,
file.
right? They have
Okay.
their own Docker files
Okay.
now, right? Now, but here
Yes, sir.
now I will now do this.
Yes, I'm understanding it.
You understand what I did here now?
Oh, okay. That means the Docker compose must be outside, like the
Yes,
root
yeah,
directory of
yes,
both the backend and the.
yes,
Oh, okay.
yes,
Okay. That's
exactly,
okay.
yes. So so now you just in the Docker file in Docker file we just use. Let me copy that conventional one. Yeah.
Mm,
Now they will just have this one. You know, you have to structure, know what you want to include them.
yeah.
But this is basic. Are they
Include that. Okay.
TypeScript? Are they TypeScript or normal?
No, no, no. It's just pure JavaScript.
Okay,
Normal
let me
JavaScript.
just remove this. All right. So when this is when you've done this now, you now come to the compose Docker compose file. Now
Okay.
you can now let me just copy these items here, and I will just explain the adjustments. Uh, Now this is your your backend server now. For example, your backend. I will just call it
Okay.
now. Let me call it backend server. Now your Docker file. This context now is dots, right? But it's not your
Okay.
Docker file is not in this directory. What this dot means, Docker file is in this directory, but it's not in this directory, right? So what I will do is
Okay.
slash. It's inside backend, inside backend
Backend.
folder. That will do is slash. You see it now?
Sorry, that context means what? After the
Context means
before you
we are building it. We are building it in
oh,
like the directory context, like
okay.
where the compose is asking you where
Where
am I?
where to access
Yes, where to look for the
accessing
Docker file.
that file.
Yeah, yes,
Oh,
yes,
okay, okay.
yes.
Okay, sir. Okay, sir.
So if this Docker file now, you see this Docker file now, if the name is
Yes,
something
sir.
else, if let's say the name here is maybe
Oh,
I call it something like Docker
okay.
file
That means you
dot.
have to rename it exactly. Okay.
Yes, you are getting it. You are following in. Let's say I call it Docker backend here. If I come here, I'll do
Yes.
dot backend.
Oh, okay, okay, sir.
You understand,
Okay.
right? Good.
Yes, I
So
understand, sir.
let's go
Okay.
back to. So now we have done this. Let me rename this container to. So when you do this now, uh,
Okay.
you are good to go,
It's
right?
okay.
When Docker Compose want to build your application, want to build the image and the container, right? It's going to use this configuration now to do that, right?
Okay, that's okay.
Yes, you understand. Then,
So
yeah,
yes,
go ahead.
okay.
Then for the front end, let me just copy out everything. For the front end, it's going to follow suit.
Okay.
Let me just see. So let me call it front end. Front end. Let me just call it just front end, right?
Okay, sir.
Then this one will be, you know what it will be now, right? Front
Yes,
end.
yes, yes, yes. Front
Yeah,
end.
yeah,
Where you can access the Docker file. Okay.
yes. So now your ports will be different, right? Ports 3000,
3,000.
yeah, and it's running inside port
Okay.
3000.
For 3,000.
Yes,
Okay.
because these ports at the left hand side here must
Okay.
not collide with this same port, right?
Okay.
But
Okay.
these two can be the same because they are running. This one now can
Okay.
be 5,000. Why this one too is
Okay.
5,000? Because they are running in separate
Oh,
containers. Separate
container.
containers.
Oh, and
Yes,
then I understand.
they don't
Okay, sir.
collide. They don't
Okay.
collide. But
O-
this one at this left
Okay.
hand side, which is the local, like the local server,
Local machines.
yes. So
Yeah.
they must not collide. If you do
Okay.
3,000 here and this one is 3,000, they will collide. It's the
They
one
will
of them will
collide. There
stop
will be
running.
conflict. Okay.
Yes, yes. So
Okay.
that is the logic there. That is the
Okay.
logic. So when you are done with this now,
Mm.
oh, forget all this depends on now. I don't want to. You can remove them, but for the front end you can do depends on backend,
Backend.
and
Okay.
the name we gave it is what backend server.
Backend server.
Yeah, that's the name we're
Okay.
going to
That
use.
means you are trying to tell this particular file and the structure now that the front end should depend on the backend,
Yes, so
like
it
in
means
terms
that
of fetching data and all that.
no, it means that Docker Compose will now first start the backend server before starting front end.
Oh, okay, 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 okay,
That's because
okay,
you are telling it that it depends on this. So it will, since you know that it depends on it, you first start that one that it depends on before starting that one,
okay,
right?
okay,
Okay. So now it now depends on how you now configure how you want to in your backend in your front end. Let's say your front
mm.
end now you have you have a VM dot variable file.
.env,
Yeah, that's you did something like base
yeah,
URL.
URL,
Yeah, for
okay,
now this base URL now you now say okay you can now use localhost for the base URL.
even in on VPS.
Yes, because it's inside local machine inside your system. This local host means that um, your app The front end and
Mm.
the back end are inside the same server, so they can access each other
Okay.
via local host. It
Okay.
is when the
Even on VPS.
yes, it is when the server is in another service. Yeah,
Locations.
yeah, another
Okay,
server.
another.
Yeah,
Okay.
yeah.
They
But
now
if
use their IP address for that.
yes, you use the IP address,
Okay.
right?
Okay. It's okay.
Then the
Thank you.
ports will be the 5,000. This outside one.
So the backend ports.
Yes. Well, there is um there's a way we can okay. This local host, right? You can do it this way.
Mm.
That instead of using local host, you can use backend server.
Okay.
The
That means
name,
the same name you
yeah,
use in
the
your
name, yeah,
Docker
yes,
Compose. Okay.
yes, because um, Docker Compose we try to Docker will try to do communicate via their names and the rest. So
Oh,
you just have to figure out which one will work if you use this or use
okay.
localhost, right? But from the port
Okay.
mapping, no, you need to use no, you don't use to use localhost. You need to use the name or the network.
The name.
You
Okay.
need to create a network. I didn't talk about network. I didn't talk about network. There's on the Docker Compose there's network configuration. Like when you create a network here, I think it's called
Yeah.
network.
Okay,
When
you can use the network now. I understand what you mean
yes,
because,
yes. If you
like, if you create a network, you give the network a name
yes, so yeah, if you
that
give it a name
both container can
exactly.
communicate.
Yes, both all the
Okay.
services can
Okay.
communicate on that network.
Communicate on that network. Oh, okay.
Yes,
All
yes.
right.
So the only difference is with
Okay.
their port, where the port they are running on, but they
Running
communicate on the
now.
port on the content
Okay,
on
sir.
that network. Yes.
Okay, sir. Okay.
So that is it. I don't know if I
Okay, Christian,
yes, boss.
if I may ask, where did you copy this code from? This Docker compose dot YML.
Okay, why I copied it to use here?
Where did you get it from?
Okay, where I got it from? I something
Yes,
I've been using I have a project I created it, so I created it. It's online though. If you can get it,
it's
like
online. Oh yeah,
I will share
just
it. Don't worry, guys.
oh,
Everything here I will share. I don't. I'm not
So,
gatekeeping anything. I will share everything to you guys. You
okay,
will see.
sorry,
okay.
sir. Sorry, another
Yeah.
thing.
Yes.
Sorry. I saw you using dot Docker ignore.
Yes.
So
Exactly.
what are you trying to like? Is it that Docker ignore means that Docker will not access that file, or when you are pushing it to the GitHub will not ignore the file?
Yeah. Docker ignore means when you are copying the code,
Yes,
your code
yeah.
from your machine to the to Docker
The
image.
Docker file.
Yeah. To Docker.
Okay,
Yeah.
Docker image. Okay.
Docker will not copy it. You don't want those code, those items to be copied
Oh,
into your image. You know, basically
okay,
Docker image
okay.
is just is it's file itself. If you look at the size here,
Yeah,
yeah, if you come to these
it,
images, see their sizes. They are large
it's like
image. Yeah.
they are lightweight.
Yeah,
Okay.
no, no, yeah, they are lightweight, but they have size. Look at this one. Now is this blog app I created. This 182
Mm,
megabytes. So they are files. They are files
mm,
themselves. They are files themselves, right?
okay,
So
okay.
anything you don't want to be copied inside the image as file, don't you add it in Git in Docker ignore.
Docker ignore.
It's just like Git ignore.
Okay, okay.
Anything
Okay.
things you don't
But
want ignore in your you don't want to be shown in your repo GitHub repo. You
mm,
put it in Git ignore.
yeah.
Yeah.
Okay. So like as you put because in your own now I saw the .env. Sorry for the stress. I
No,
know
no,
that you
no,
have
no
really
problem,
tried.
no problem, no problem.
Sorry,
I'm good.
sorry, sorry,
Okay,
sorry. Thank
let's
you so much.
check.
Thank you.
Yeah,
I just want to like
yeah. So you
okay.
don't want
Like
this
you
one.
have .env.
Yeah, you don't
Okay.
TMV. Yes, you don't need it. You don't need it inside your image. It's a secret. The only place you use
Okay.
when you need .env is when you are running your application. When you do Docker run. You're running your
Okay.
image, Docker run, right?
So you have to copy the .env to the
No, 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 no.
to the
Okay,
command.
I think I
Okay.
no.
How do you do it?
This is how you do it. Let me show us image. The
Okay.
images that are here, right? Now this is the image I deployed, right? I pushed to
Yes.
Docker Hub. So if I want to run this
Oh,
image, right? Although
yes, sir.
if I tell you, okay, if I say tell you, okay, go and pull this my image and run it in your server in your local machine, right? As I've told you that, I'll tell you, okay, it uses .env.
Yeah.
You need to provide some very secret some variables, variables to
Okay.
it.
Okay.
Yeah. So
Okay.
what you need to do now when you want to run these images, you do this docker run, then the name of the image, which is OKK Christian, right?
Slash blog app.
Yeah, slash blog app. You need to put, let's put this tag, right? If you don't put the tag, Docker will attach latest to it, and we don't have this one latest. We only have this. So
Latest.
if you don't add the tag, it's going to complain that it doesn't. It's going to be looking for. It's going to be looking for something like this when you don't
Latest.
attach tag. Yes, and you don't have it.
Okay.
Yeah, so
Okay.
you need to put the tag. It's only when you tag it latest that you don't need to put the tag when you want to call
Okay.
it.
Okay.
So
Okay.
now I want to run this image this way now, right? I need to port map it, right? I'll also tell you that
Okay.
it is running in port blah blah blah, right? You need to know the port, right? So
Okay.
and the port
Okay.
I've told you that it is in port 5,000, right? So you now do,
Yes, sir.
yeah, port 5,000. Then you can now put your own ports. Maybe you want it to run in port 4005 in your own machine, or you must put 5,000 because I've told you that the app runs in port 5,000. Now,
Yes,
since you
sir.
have done this now, right? There's one last thing you need to do. You need to specify. You need to tell it, give it an env file, right? And
Okay.
if you have where you are running this command now, the directory, if you have a env file, that is, maybe you call it maybe you called it my env .env, because env must start stop with env extension.
Dot. Okay.
Yeah. Or if you just name it env, you put anyhow you want to name your file, you name it that way. So you must use this flag hyphen env file, env hyphen file, then you give it the name of the env file. Then it means you have supplied the env configuration of this image.
Okay. Where is the .cmv file is coming from? Is it from this
Is it, you have already
folder that you
created
are
it?
pulling?
Yeah, no, this no, it
Okay.
is in you must create it first. You must
Okay.
create
Okay.
it in
Okay.
this directory. Like, okay,
Oh,
let's say
okay.
I am here. Okay, let's cool that now. Let me open another directory. Let me open another directory.
Okay.
Let me create this directory now. I've created this directory, right?
Yes, sir.
Let me open terminal. Okay, open in terminal, right? Now, if I let me type all those things. Let me just do OKK Christian slash blog app. The tag is v 0.0. Let me 0.1, right? Now,
Yes, sir.
now hyphen env slash file, right?
Oh, okay.
Like, okay, hold on. Let's say my env.env, right?
Yes,
Now
sir.
I'll come to, I'm inside this demo. Inside this demo. Is this demo inside this demo
Okay.
folder I open this
Yeah.
terminal, right? So I will now come and do this. I'll create my env.env.
Okay. Okay.
You see, I've created this env file now.
Yeah. Yes,
Inside
sir.
is them. So that's the name I gave it here. So I've created. So when
Okay.
I run this
Okay.
Docker now, Docker will look for
Mm.
this env file to use it to execute this
Oh,
image.
okay.
You understand?
Okay.
So you must create the file inside the directory. Or if you create it in another directory, you have to
Mm.
specify the directory path and the file name, right?
Okay.
So
Okay.
Docker
Now I understand.
will look for it. Yeah, yeah. So you get
Okay.
bar.
Yes, sir. Yes, sir. Thank you so much, sir.
You're welcome.
Thank you so much.
You're welcome. Is there any question, any confusion again? Guys, please practice. Please, you have to practice. I know you have to practice these things. They are very easy if you just work with them. Honestly, they are very easy. You have to work with them. All right. All right, guys. Thank you very much for. If you
Okay.
have any other
Okay.
question, you can reach out to me. Reach out to DM. I don't mind. We can go on a meeting and we'll still discuss if you have any other question.
Oh,
Do you have any question now? We can ask.
thank you
If you
so
have
much,
any
sir.
question
God
now,
bless.
if you have any question, you can ask now. No problem.
It's okay. Thank you so much. I really appreciate it. Thank you, sir.
All right.
Christian,
Yes, yes, boss.
I saw that you were explaining to him on how to Dockerize both front end and back end.
Yeah.
So that does it mean that it is a best practice to to Dockify both the front end and the back end?
It is best practice to Dockerize your applications, right? But it's
Uh,
not best practice
yes.
to host your front end and back end inside one server.
So for the example you were giving him, was it in the same server? It was on different server.
No, the example we discussed is the same server. He told me that he wants to learn how to Dockerize the front end and back end in the same project, like in the same server. So I just showed him how to Dockerize it, how to Dockerize something like that. But it's not best practice. When companies don't like to host the front end and back end in the same server, right? So they
So I think, what if you change the ports? For example, you used the 3000 ports for both the front end and the back end. What if the ports were changed? For example, for front end, we could put 4000, then for the back end, we could put 3000.
in the same
Will it be
application,
different stuff? Yes, in the same application.
in the same server, right? If you one thing about ports is that if you are running the two applications that are using ports in the same server in the same host, right? In the same host, the ports must not clash. The ports must be different, right? If you are hosting them in the same server in the same VPS, right, or EC2, if the front end is running in ports 3000, the back end need to run in another ports like 5000. So they must not be 5000 and 5000, right? Now that is how you run it. Now if you want to Dockerize the two of them, like both of them, you want to Dockerize them. Now when you think about Dockerizing, right? Dockerizing is just like you want to isolate that app. You want to put it inside a container to be running. So when the app is inside a container, it doesn't have any collision with the outside environment anymore like that, right? So if I have front end running in port 5000 and I have back end running in port 5000 at the same time, I can host those two applications
Okay.
inside the same server and they will not collide. How will I do that? I will just Dockerize the two of them. Front end will be running in port 5000, back end will be running in port 5000, but they will not collide because they are Dockerized inside their own respective containers, different containers. So they will not be able to collide with each other. Then the question now is that how does people access the application. Like, how does the two of them communicate now, right? How do we two of them communicate, or how do people outside the the system communicate with them? Like, if you want to access the front end or you want to access the back end, how do you do that? Now, remember your port mapping. When you are running the Docker container, the port mapping that you do, the port mapping now for the front end and the back end must not collide. The front end port mapping of the front end and the back end must not collide, just as I showed him here. Here, let's say this is the back end and this is the front end. This port, this is the host, like where your host, the port of your host of your host. Why this is the port of your container? So these ports here and this one here for the back end and the front end, these two, they can be the same. 5,000 and 5,000, they can be the same, right? No problem. The app will run. But these ones at the left hand side, this one and this one, must not be the same, because the your application, the front end and back end, are running inside the same server. They must not be the same, because this is where they have access to the outside localhost machine, your own machine, your server machine. So I don't know if I'm
Yes.
making sense. It's just
Yes.
yeah, think about it. It makes sense to you. It will make
So
sense.
it will be difficult to map.
Yes, the
Uh,
collision. If you make it, if I make this one 5,000, this left hand side 5,000, and this one 5,000, it will be it will collide. The two will not run. One of them will not run, rather. All right.
so that means that the best practice is to have a separate Docker.
Hello, hello,
Uh,
hello.
we can have different ports.
The
Did you get
solution,
me? Hello.
the solution is to make sure these ports, the left hand
Yes.
side ports, are the same, are different. When you are hosting the front end and back end in the same machine, the same cloud server, in the same server, right? Right. Sorry, I don't know. So that's basically, hello guys. So that's just the thing there.
Come again. Yeah, your network, I think.
Hello, can you hear me now?
I'm saying, come again. Your network. Yes. Now I can hear you.
Okay, yeah,
So
yeah. So
what were you saying
what
about?
I'm saying is that this left hand side ports for the front end and the back end, right, must not be the same,
Yes.
right? The front side and the right hand side parts can be the same, no problem, because they are running in their own separate containers, right? But inside the
Yes.
same server, inside the same host server, right? So this front end, this back left hand port must not be the same, but the right hand port can be the same. So basically, that's the idea there.
So what about during mapping? Will we use the port for backend or the port for
No, no, no. This is
frontend?
this is a Docker Compose. We are already doing the mapping here, right?
Oh,
If you have Docker Compose, if you have Docker Compose,
oh,
you don't need to be running.
okay. By having 5,000 and by having 3,000, we're already mapping.
Yes, that's mapping. So if you have Docker Compose, you don't need to do this, run this command docker run here. You don't need to do it. This docker run is actually, you are trying to run one image. You're trying to start up one image container, right? Just one, right? But Docker Compose, you want to manage all the image at the same time. You understand?
Yes.
You want to manage all the image, like your front end. Your front end is everything is inside one. That's like I demonstrated here. This is the back end, this is the front end. The back end is dockerized because it has Dockerfile. The front end is also dockerized because it has Dockerfile. So you want to run these two images, you want to run them at the same time. So use Docker Compose. You have to create Docker Compose for them. Docker Compose will help you to manage them. So using this command, instead of using this command I specified here, instead of doing Docker run, instead of using doing Docker run for each other, because if you want to run it one by one, you do Docker run for the front end and you do Docker run for the back end, right? Instead of doing it one by one for them, you use Docker Compose. You use Docker Compose and manage the two of them at the same time. I don't know if I'm clear.
Yes.
Yeah. So this is that's it. So this place here, this is port mapping. So this thing you see here is basically this thing here. It's basically this hyphen p here that we do there. This thing here is basically this thing here, right?
So
Why?
so if I yes,
Go
so
ahead.
if I want to maintain the best practice, I should have separate Docker Compose.yml on front end and another Docker Compose.yml on backend, since that is the best practice.
Uh,
More for what
no, it
to do.
depends on, are you hosting the front end and the back end in the same server, in the same cloud server? If you are
I
hosting,
want to, if I want to host it differently.
if you want to host it differently, then you don't need to do it this way, right? If you want to host it differently, you don't need to do it this way. Of course, you have your front end folder, then you have your back end folder, right? Then you have to
Yes.
create Docker file for each of them, Docker file for each of them. Then you can
Yes.
you can deploy them, and you can create image for each of them and deploy separately. You don't need to bring them here and start and create a Docker Compose file for them here. No, no. This Docker Compose file is helping you to manage these two applications simultaneously in the same server, right? In the
Okay.
same server. This is my in the same server, in the same server. Not if they are in separate servers, like the separate server you hosting there, you don't need to create Docker Compose for each or for the two of them. No, you can you can create Docker Compose for different, for different for their own folders. You can create Docker Compose for front end and Docker Compose for back end, or you create Docker file for front end and back end separately, but not this way. I did it. Right here, I created the two direct applications are the same project directory, and front end and back end separated them, and we created a compose Docker Compose for them. So because I am
Okay.
hosting them in the same server, but if I'm hosting them separately, I don't need to bring them here. I'll just delete this Docker Compose and manage them. I'll just deploy front end to its server, deploy backend to its server. Then I'll use this command, this normal Docker run, to start them and do run it in their own separate servers.
Okay.
You understand, right?
Yes, I think I have understand.
Okay, so if they are in separate servers, you don't need to manage them the same. Even if they are in the same folder, even if the front end and back end are in the same folder in your machine, in your personal laptop, right?
Yes.
You don't need to create Docker Compose file for them. Since you are deploying them separately in this different server, you don't need to create Docker Compose file for them. You just need to create Docker file for each of them, right? Docker file means you are containerizing them. Then you go to you deploy them separately. Then you use Docker to start them in the cloud server.
Okay.
All right. By next
Thank you.
week, hopefully, I think we're going to deploy this thing, and I will look for um, an AWS account that we're going to deploy these things. We're going to deploy the Dockerized application. We guys, we're going to see it how everything works. All right,
Okay.
guys. Thank you very much. Today has been a long day.
Thank you so much.
All right. Have a lovely weekend. Thank you. See you next week.
Thank you.
Yeah, you too, sir.
You will
Thank
send,
you, sir. Thank you.
yeah, you will send the notes
Yeah,
and
everything. I will send it. I will send everything. I will send everything.
thank you.